Welcome to day one of the 2023 MOVES Open House. We have several great presentations in this video, including a keynote by our president, the status of the MOVES curriculum, and several presentations on interdisciplinary work MOVES has done with others on the NPS campus. We hope you enjoy. The first presenter is Vice Admiral Anne Rondeau, United States Navy retired, the president of the Naval Postgraduate School.
So I really need your input as the users, as the experts, as people who care about this work. And so please give us that input. So we're in a long-term strategic competition, and we've heard that for quite a while now. But U.S. maritime dominance is at risk. It's not just about numbers of ships, carriers. It's about how we think in a maritime way and how we operate, see, create. So we are at a maritime dominance risk in the current era. Naval Postgraduate School certainly also understands the competition that we're in for how you understand, organize, deliberate, and exercise mental, cognitive, intellectual, and operational agility success. And what I call the physics of the institution, it's different density, volume, mass, speed, and that is part of the challenge in front of us. So understanding the environment before getting into an environment that is profoundly unknown is really important. So we are at a strategic inflection point here. And I want to start that off because I think that what Dr. Blau values and what you bring is how you have been involved in this ecosystem here at NPS can help us to be better, be stronger, and have your own voice and frankly your own tattoo on what we are trying.
Unfortunately, due to technical difficulties,
so in
the first few minutes of Vice Admiral Rondeau's talk were lost. We now join her in progress.
Call on the Commandant of the Marine Corps. I asked him for 10 minutes and he gave me an hour and 15 minutes and told me to study Force Design 2030. I did that line by line. Good thing I did because he could over his Force Design 2030 line by line. And in that, constantly fed it with throughout that was I need to have a different Marine Corps that thinks a bit differently and critically at the point of need. So throughout that hour and 15 minutes, we went over line by line of design. You take the CNO's guidance of 2022 and it is navigation thing. And it calls for the Navy to adapt, learn, and improve faster, whatever that means. Competition. And so the core of get real, get better is to analytically discern and understand what's in front of you at the point of need. Not only strategically, but also operationally tactically. And then to strengthen the culture of excellence in how we think and what we are to and what we are how we are behaving. And that culture and acceleration are really important to understand how we change those things. So, as the Department of Defense's primary graduate institution for STEM and for national security, in terms of how we are organized as to how STEM affects strategy and strategy affects STEM, we have an obligation at NPS to be meeting that challenge. So we need to exemplify the agility of learning, the adaptation, the adoption, and the agility of learning. And that makes learning a rather different kind of an experience. It means it's fluid rather than static, and it is continuous. It is not episodic. So to be able to do that does require us to think about things like modeling and simulation. So our next line of efforts here, we have really worked to integrate, to flatten, to make more of our work lateral and horizontal than vertical. And we've done that in a number of ways. Certainly one of the ways that we've done it is to eliminate schools per se and to integrate more of the interdisciplinary experiences for our warrior scholars and all those who are students and the faculty to be able to think about things. No problem is solved in one single discipline. Not one. And so being able to understand that you're going to see problems, and by nature they're interdisciplinary, and broad as well as deep is really important. So we have 4 things that we are working to do. We are expanding the reach and the impact of naval education, and we are certainly disrupting some of the long held beliefs about what that looks like and how it looks and what it does. We are strengthening the alignment and the impact of basic and applied research and making the application of research relevant and able to be transitioned outside of us, which is rather also disruptive to the system. And we're working to lead naval innovation and developing and birthing ecosystem of innovation through our behavior and through also our partnerships with industry and academic centers and partners. And we are advancing the institution to support our vital mission of educating the force and fight. So what does all this have to do then, if that's what we're doing? Why the heck are we doing that? It's in response to the environment. We have really brilliant people here who understand the environment and understand the need for change. But the guidance is abundant. It's abundant. There's no lack of guidance. But what there is the ability to sometimes bring that guidance into a discernible response capability. So interestingly, in 2021, the Defense Science Board had formed a task force on gaming, exercise, modeling, and simulation checks. All of you will have read it, I'm sure. Most of you have it memorized. But when I had one of my really smart advisors say, hey, Alan, you need to take a look at it, I was struck by a number of things. So let me take the moment here on to share that. And one of the things said in that report was the pockets of GEMS excellence developed by DoD have become isolated over time and now often lack the necessary resources to support the DoD's mission in an area of great power competition. So we continue in our trials and keep that in modeling and simulation. So I will tell you is that we then think about moves, but let me go back and think about what else have we gotten from the PSB report that also informs Dr. Bilal and our moves transition. So what did the report look at? Digital engineering and acquisition, training, experimentation, high quality virtual exercising, evaluation and testing, integrated use of technology-based enablers, and promoting governance. NPS can touch all of those things, and we should. And so there is a piece here that says this report belongs to us, and we have an obligation to continue. But one of the last things I want to talk about here from the report, it says, while the DoD has pockets of excellence and innovation, the task force observed that it lacks necessary integration, resources, and talent to reap the full benefit now available from GEMS. Particularly lacking are mechanisms to effectively integrate insights derived from GEMS into senior leader decision making about defense requirements and the acquisition programs. What's really interesting about this, though, is it not only talks about warfighting, it talks about administration. It implies financial management systems. It implies all of the things that support in front the warfighter requirements for the pointing in. So with that in mind, then what does further inform and yes, what we're doing? So I'll tell you is that moves. So we've had a journey with moves, and back when it first began, it was that one of a kind development. And I can remember going to an ITSEC conference and being particularly captivated by moves, the NPS. I was a lieutenant commander at the time. That was back in a long time ago. Planned for but I was at ITSEC, and the moves display area was fascinating to me, and it was cutting edge at that time. And what we want to do is to maintain that cutting edge. So moves is kind of one of a kind of capability that provides gems and workforce development, but also it is foundation. And the applied research area is where it can be particularly foundational. And it is positioned to be that central connector and convening place for GEMS collaboration, get it out of the tribes, get it out of the things that the DSP had said was a problem, and to meet the future challenges in training, in systems engineering, in acquisition, in deterrence, and in warfighting. But here are some of my questions for you, for government and for industry. How do we think about past experiences with moves that made it that one area, that one kind, that one of a kind of capability? How do you think about the past, about all the things that give it merit and value, and those characteristics moving those forward to advancing knowledge, skills, and the capacities of today's workforce, while leveraging the expertise of the virtual natives who today are monks? How do we do that? How do we merge modeling and simulation and generative AI to speed development of the tools, the processes, and to generate the kind of C2 for all domain force against the peer competitor? How does this group solve the most consequential challenges today while developing next generation capabilities? So my observations since I have been here about DoD and the U.S. government, and I've seen this in my previous slide as well, is we have merit and honor and frankly proven performance to think that our problems are unique. It's sort of art in terms of what war is, what warfare is, what battle is, what combat is, all of those things that certainly define a military force. But are we so unique that we cannot really come to understand that there are things that others can teach us? Now, we talk about this, but I would submit to you that we can even advance it more. Supply chain. When we talk about supply chain, oftentimes we talk in terms of logistics and contestant and fun. When I was the deputy commander at TRANSCOM and we were in the war in Afghanistan, first off, I can tell you is that logistics and the contested and environment was also the issues for craft aircraft for the civilian aviation world, and it was for all kinds of truckers and shippers. I will tell you is that the first out of the block for augmenting MAP, AMC, the Air Force was not U.S. carriers, it was DHL. Because DHL had actually done some modeling about what things looked like, and they were ready to go, and their insurance companies said yes. Our U.S. carriers followed through and followed up, but it was that. So you had an international carrier, commercial, alongside U.S. Air Force, and they were looking at logistics and environment. And if we did not run anything during the pandemic, it's about supply chain and how the civilian side does affect the military side. So what is it that industry does that we can learn even better and faster? And are we set up to do that? Are we set up to do that as a government? For industry, how are you able, and I wrote this down because I really, we are working with these kinds of problems today here as we work our moves and our creators and our partnerships with industry. So how do you understand the complexity of the DoD and environment? One of my observations is that the complexity of gaming in the commercial world and of modeling and installation in the commercial world is different than the complexity of the military. And I think that is something that we need to have a better understanding and a discernment. So how can industry adapt your tools to yield the decision advantage that DoD needs? And it is pretty important to understand that the risk piece here is really quite different. And so working to understand that. So I would tell you is that, transformation and PS can be a place where the DSB mentioning about silos can be solved, where we can convene and understand the integration of assets and industry and military and everybody else. There can be that sandbox moves that helps us to understand these things better. So that sandbox that's here is a way to answer the DSB issues, a way to answer some of our own frustrations about what is going on. So how many, I don't want anybody to raise their hands, but internally for NPS, how many people are here from CS, IS, MAE, additive manufacturing, OR, and how many on the industry side are here who are the data developers, providers, deliverers? So who is not here, there should be here, and next time invite them to also be here, because presence matters and that voice matters for the different points of view. The other observation I have is this: if we are episodically satisfied with our victories. So what happens here in my view is that industry and military get together, DoD get together, let's say in creatives, and what that partnership can do is the exchange of intellectual property. But what industry will then do is spin off and walk away. And what the DoD does is that it pulls. And so what happens is we have those episodic victories. We think that we gained something, but the notion of continuing and thinking about this area for discovery and exploration that M&S and MOVES gives us is completely under leveraged and sub-optimized because of trust. And so I think that is something to explore this week is how do you understand trust so that the intellectual power and the brilliance of the collective here can really advance MOVES to be even more than it is. So the comparative advantages of MOVES then brings together academia, the fleet, the force, the NR and DE, which we are now the Naval Research and Development Enterprise, which we are a part of. So I think we might be the only DoD institution that has a foot in education, graduate education in STEM, and a foot in the NRD for research and development. And we owe that kind of 2-foot stand a better advantage. And than we had. So the MOVES curriculum represents an opportunity to reinforce a core mission of NPS. That's the upskilling of generational leaders to both critical and creative thinking. Interestingly, remember when Alchemaev was the MOD for the Soviet Union? It's interesting that General Gerasimov, the current Russian chief of the armed services, is giving us a term for foresight. And we think about that. But what's it mean in analytical terms? What does foresight mean? So this is less about seeing the future than it is about creating an opportunity to imagine and assess what the future could be and shaping present decisions, options, actions, and investments to those ends. And given our paucity of time and magnitude of our distraction every day, effective modeling and assessment, really important, the assessment within a capable and environment can offer, should offer, must offer, as yet unrealized wisdom to future flavor. Additionally, as I got some other input, one of the other comments said to me was developing schema, both technical, ecosystem, and decision environment schema that account for the increasing volatility, uncertainty, and dynamism of the geopolitical, military, in information markets, driving maneuver warfare decisions is truly beneficial to COCOMs, combat commanders, presidents, the White House, anybody developing operations. Particularly in the era of this strategic competition and integrated deterrence. We often hear about how the West plays chess and China plays Go. I've never accepted that binary comparison. Because in both Go and chess, the players have exquisite and perfect knowledge to what is observable. So we use sometimes metaphors that are very effective, and sometimes metaphors that are not. And if we think about the fact that in those games, everything is observable and knowable, an exquisite perfection of knowledge, that is not how we should be doing war games or modeling simulation. We should be exemplifying uncertainty, exemplifying what is unknown. The famous line from Donald Rumsfeld: "You don't know what you don't know, and that is what will kill you." So we have some interesting moments here, and I really urge this notion of really working in a collaborative way. So I was stationed in Louisiana, and I got a chance to in my social time to learn the Louisiana two-step. It's kind of like a square dance, okay? But everybody goes and you have a partner, and you're twirling with that partner, and you are twirling in syncopation with other partners in the circle. It could be a circle of 4, 6, 10, 20, 40. But you are circling and also circling. And in some cases, when you're really good at this dance, you get to change partners while you're circling and circling. So you're doing two kinds of a tight circle as you in a group are doing a large one. And you change partners. And sometimes you stumble, but nobody loses their rhythm and the syncopation of that circle. That's a perfect Louisiana two-step. Are we ready to dance? That dance. It takes time, it takes knowledge, it takes trust. Everybody else knows what they're doing. And it is what the challenge is in front of us. So one thing is certain. Our collective future is in the DoD and the Joint Force. And for industry, it is there also, and there is this extraordinary integration moment for us between the government and industry, and that is to break down the barriers so that we that don't take down the boundaries for proper legal, all those things, but takes out the barriers within the boundaries, so that we're in the arena playing creatively, and yet we know what is foul. So our collective future is in the DoD and the Joint Force, and it is going to be bound forever to data. But what M&S could also do is to also not only understand the data, but to understand the role of instinct, to understand the role of agility and of adapting. And so the data will inform us, but the data should not drive us without us having a sense of judgment and discernment. And that takes practice. So what M&S should be able to do is be that sandbox. And so from a robust MOVES curriculum that you all have had a part in, we should make it a source of confidence that we are developing and challenging assumptions, that we are honing discernment and judgment, and that we have an informed capacity for capable decisions that will fight or avoid the fight, but always win. Thank you. That Dr. Boa, when we available for answers, questions and answers, I told him I was incompetent to some of those questions, but I'll try. So anybody have any questions? Yes, sir. Chris, yeah.
Not a question.
Yeah.
One of the things I wanted to mention is I think when you said, are we ready to dance? And you know, I'm absolutely ready to dance.
Yeah, but it's always on.
So one of the things I wanted to say is that in December, we're getting connected to the ESTRA. It's actually a huge move forward for us. And that's all part of a NIMSO project, Navy Modeling Simulation Office that I'm working on. And in December, we plan on doing a test with China Lake in their integrated battle space arena. And I feel like through this project, I've gotten a chance to look at a lot of the issues that are, you know, say China Lake bases, point of view bases, and you know, doing some of their research. So and then I've also recently found out that you know, we're going to be able to connect with naval labs, but two MEF, one MEF are also getting the ESTRA. So that'll be another opportunity for us to be more engaged. So I wanted to thank you for pushing forward, getting connected to the ESTRA.
Well, we have Scott Bishop and the entire financial management team and ICAP and that collective. Yes. But they, I mean, you do prioritize and you do stratify and you do work to stratify your priorities, and we did make that that past 2 years a budget priority. But now that we're stabilizing our budget, we can really do it now. Yes, thanks, Chris. Yes, sir. And I thank you for smiling at Joe.
So in a high technology area like modeling, it seems that our peer competitors recognize the value of this technology and are scaling their workforce in ways that autocratic systems allow, in some ways, to be more efficient. How do you think Naval Postgraduate School moves can scale to better address the challenges? It's certainly a problem I see firsthand on the Navy modeling and simulation side, in workforce development, education and training, human capital management. Some of the other services seem, especially some of the other services, I guess I should name names, seem more technology, to adapt technology to promote people with that technology savvy in a way that doesn't seem to be as easy in the Navy. I can see that dynamic change.
Okay, you have two different questions there. So let's take the first one. We're in this kind of vortex in our country, seeing higher rate, seeing industry, seeing organization, Everybody has to change everything all the time. Everybody wants everything. That is an impossible task. So I think that this notion about teaming and collaboration. So that's what then makes that whole, is the network. So Chris's comment about the warfare centers, the labs. I think we have an obligation, and we are working to really work more closely with the warfare centers, to more closely work with NIWICs and Warcom, all those folks, to really bring together their brilliance and their and bring it together as a network, and not make it so much a rugby match as it is more of a great basketball game. So that people know what they're doing, and that they bring it all together. And then that network solution is integrated, it's diverse. So we got to get around that. That's one of those things you cannot legislate, and you try, but it's not going to work that way. You got to have culture. It says that our nation, this nation, which is a democratic nation, they do that. You're never going to get to the scale, but sometimes I look at this Motorola compared to Harley, not but the small, really powerful branding company that can outpace everybody. Okay, I guess that now Hyundai is doing that all of a sudden. But that you're smaller, but that you're really good, you're tight, you're focused, and you can get that done, and you're really good at what you're doing, and then contribute to the others who aren't doing that. So I think it's about networking. I think it's about collaboration. I think it's about good competition that gets you best results, but good competition that also says, and they also can help us to get better and stronger. Hard to do. It's about culture, but I think that that's really important. To get to the issue about Navy versus everybody else, I understand what you're saying. Organization, I think you're right. Air Force, Army, Marine Corps have a bit more of in the past a coherent, cogent way of looking at how they educate and train. But frankly, I think that there is an extraordinary you play with what you got, you play the cards you got, and you try to do that. There is within the Navy and within all the services an extraordinary amount of initiative and innovation that can get us to where you want to go. And it's a conceit that we say that this is only now when we're going to innovate. Every soldier, Marine, sailor, and airman who's been in combat innovates every moment of his or her life, right? They innovate, right? So I think that it's about the mindset, about the culture of independent thinking, about really acknowledging that. We do that pretty well in the Navy. And the other services do as well, but Navy and the Marine Corps are really good at that. So play to two strengths. Organizationally, the Navy's getting there, to tell you the truth. They are. There's a lot more coherence than there ever has been about training and education in the Navy post-Cold War. Pre-Cold War, I mean, during the Cold War, it was very block and tackle and very well done. But there's there's something very extraordinary in the Navy. We can put guys and gals in cockpits of fast planes and put them in submarines and put them building runways in some island, and that they all, it is an extraordinary feat of human imagination as well as competence. So we need to celebrate that and make the best of it, and not always poor mouth everything we're doing. But organizationally, strategically, and resource-wise, the Navy's getting better at it because they were not as good as the others. What else? Okay, thank you for the privilege and the honor of your time. You had smarter people up here tonight, but Emory wanted to hold me accountable for a change here, so I wanted to do right by him. So thank you, Emory, very, very much. Thank you. Thank you.
Unfortunately, due to more technical difficulties, we missed the beginning of Chris Darken's talk. We now join him in progress.
Right person's time to be fully immersed in modeling and simulation. We hope to produce a product, a student that can respond more rapidly to change. And I think the fact is that our students not only go out and live in the future, right? They're here on campus, but they're not working their jobs yet. They're working their jobs in the future environment. We hope that they won't only be successful in that, but also when they are tasked to help determine requirements for the more distant future, that they're going to be able to provide good feedback to their service branches. Well, that's kind of the story. And I left plenty of time here, so don't hesitate to raise a hand if you want to ask a question or interrupt here, or it certainly will be time at the end as well. All right, so I want to point out a few what I consider the most special properties of the MOVES master's degree. So one is that it is a technical degree. This is by fiat, by our sponsor. So we wouldn't, current main sponsor is the Marine Corps. There'll be sponsors across the Navy and the Army as well. They expect a technical degree, and that means deep into the programming and math. And how deep? Well, that's a question, but deep. And to me, the way you achieve that, and what gives me some amount of confidence that we're actually achieving that, comes from the hands-on nature of the curriculum. Not everything is hands-on by a long shot, but if I have a student that can come through, do a lab, do a project, do a practicum, not to mention a thesis that is hands-on, where they are creating their own simulation or their own riff on an existing simulation, or are able to test a simulation even in a mature way, then that gives me some confidence that we really have a technical degree. That's what we say. We're supposed to be producing students that have technical depth in modeling and simulation, but what does that exactly mean? It's a little fuzzy. No one's ever been able to make it perfectly clear to me, but that's what I can tell you. That's what I go by. And so I believe we are still a technical degree program here in MOVES. The second point that's nice and a complementary is that we don't require as an input our students coming in that they have already deep technical experience of any kind, really. Okay. And that's a little different from some of the very good programs that might be out there in the civilian sector, where those requirements are pretty typical. And last but not least, what I like about the MOVES curriculum is that we try to use examples that are military and are modeling and simulation based wherever we can for education. Okay. And that point varies anywhere from being absolutely key for some students to being kind of a nice to have for other students. So students that are really brilliant and really focused in on academic thinking, and we do have some students coming through like that. This is a nice to have using military examples. If you sent them, in all honesty, if you sent them to a civilian university where they don't see a single military example, and then bring them back into the force and say, okay, apply what you learned in military problems, they will be able to do that. But that's not every student that's going to be able to do that. If you really want to make sure people can apply their learning to military problems, it is perhaps, I want to suggest, safest to have them working on military problems the whole way along through the education process. Okay, so just kind of the outline of what we do. What we do require from students is they have to be here at the start of the summer quarter. We're still just doing one input a year, including now in a few days they'll start arriving on campus for the new cohort. Students need to have good grades from previous studies. That GPA is taken into account. They need to have had exposure to math or be in for a major amount of pain through the first couple quarters. What they don't need is a technical bachelor's degree, but that's still it's an awfully great thing if someone comes in and has depth in CS or math or engineering or even a pure science field. They're going to have an easier ride than students who come in with, poli-sci or phys ed or whatever. But we've had students from all kinds of backgrounds come through, and they come through and do amazing work, in my view, considering where they start from all those different backgrounds. The program is still 24 months, 24 complete months. I'll show you the matrix as it currently is in a second, and thesis is required. That's also still by fiat. From an advisor, but I think that's a good thing. Okay, so this is the whole current matrix. If you like the candy coloring, it's there to make a particular point. I hope to give you a feel. It doesn't even help me. You just got to understand. Well, so it's 2 full years. It's a lot of courses. One of the things to say right up front is it's not every curriculum on this campus that has as full a matrix as this one. That's pretty chock full. This comes from the fact, well, you can say it's from our own limitations. We have a lot of requirements that come in from the sponsor, but almost 100 knowledge items, as they're called, that students are going to need to come out of here with, and we have not found a better way up to this point of than to meet a lot of knowledge requirements with a lot of courses. So there's a lot of courses there, not much flexibility. We can make some flexibility where it's absolutely needed, but not much. Okay, and what are students spending the time with, right? So starting with the yellow, all the fun math going through, calculus, logic and discrete math, a whole sequence in prob and stats. That's already, that's a big block, 6 courses. That's a lot of weight in this curriculum. Students all needed to graduate knowing programming. They need programming for 2 reasons. I mean, they need programming just to be able to follow the concepts and things that are going on in the rest of the curriculum. So we're, to some sense, scratching our own backs with the programming. And on the other side, there's an explicit sponsor requirement that students will be able to program. And we don't graduate software engineers. If you want someone who really knows software engineering methodology and is, you know, really an absolute top light programmer, I think there are programs even on this campus for doing that, then moves, but students need to be able to produce code if they're called upon to do so. Okay, so there you go. That's 3 quarters gone. Then we have 7 quarters, all the things in white, starting with this course up here. It's a little hard to tell white from light, right? But it's this one, and then all these down the side of this one. These are pretty much all courses that you just wouldn't see in any curriculum other than modeling and simulation curriculum. That's why I'm calling them our core. I mean, the one exception might be this course here, which is also taken by all the students doing operations analysis or things like that. So it's a pretty common course on this campus, but with that one exception, these are all courses that get pretty deep into stuff that is mostly of interest to us as modeling simulation professionals.
Just scoot over a foot.
Scoot over. Sorry.
Our audience wants to see your face.
Oh, okay. Okay. Maybe I'll look up this way then. We also I teach some computer graphics. There's like a basic course in fundamentals and theory and an applied course. I consider this to be so when I started here in moves about 20 years ago, that was a nice to have, and some people considered that a very fluffy topic for modeling and simulation. But I think at this point it's an absolute necessity. You know, you can convey to a human user using graphical means, you know, what is happening inside the simulation. We've got artificial intelligence. We've got our own basic course in AI, very similar to an introductory course you take anywhere. So maybe a little more simulation focused, and then an advanced course that really goes hot and heavy into how you can take AI techniques and turn them into behaviors that work in your simulation. We have a expanding sequence now up to 3 courses here in purple, starting from basic networking to interoperability to very LVC focused. I think that's a real strength of the curriculum and something we've been working on building till now. And by we, I mean mostly Chris Fitzpatrick. So he'll talk to you about that. Talk to Chris if you're interested in details on that topic. Human factors, we still have 3 courses in the curriculum on that, and maybe you should have more. It's still a vital part of what makes a technological tool actually have value to the end user, is having good human factors built in. And plenty of students still do their theses in that area, as some of you know. We have a couple courses I couldn't fit into any other category. That doesn't mean they're not important, though. We have the fundamentals of system engineering up here. I think students get quite some use out of, at least on a good year. It's service courses from other departments sometimes get the great instructor and sometimes don't. You know, so you can't, it's not an absolute guarantee, but I think the material is very, very good. And we also have a management-oriented acquisition course. which I think is quite valuable. And then these blue boxes down here are the only ones that are not, normal courses where you're either sitting in a classroom or sitting in a lab, right? These are our so-called thesis blocks where you actually give students some amount of dedicated time for their thesis. I think pretty much any student will tell you that that is not nearly enough to actually produce a thesis, so they're going to be still stealing hours and days from other things to make it happen. But sometimes it does happen. And in the mix here, some of the 45 courses are things which are more practically oriented, 4501, 02, 03, 04. Those are so-called practical. So those would be more lab than sitting in the classroom. And then on the side, last but not least, we have short courses, the seminars, things that are just a couple credits, don't usually involve a lot of homework and work outside of the class, but still we feel they're important enough that we still have to take yet more time from the students to make them happen. Okay. So that is the curriculum. Now, just to give you an update on what's been happening very recently, last year at this time, we were having a face-to-face meeting, I think that's correct, where we wrapped up the last curriculum review cycle. So we have a cycle that's traditionally been 2 years on campus. I've heard we might be moving to 3, but I haven't gotten an official word on that. So it's an ongoing cycle. So we're just at the point now where we finished one cycle and we're starting the next one. So what are we doing and what should we be thinking about for the next cycle? Let's let that be the topic for the rest of the time here. First of all, the face-to-face meeting doesn't end anything. We do try to get all the stakeholders around the table and get kind of a thumbs up and a smile from everyone that we're on the right track. But it usually takes months after that to actually get things signed off. So General Heckle signed off in end of last September. So since then that terminates the one cycle and gets us into the next one. Okay. So our action plan that came out of that was it's more than I'm going to talk about in detail here. I'm happy to say more, but it had 9 items on it. But 2 I really want to point out because they were much bigger items than the rest. Most involved at most adding a unit to a course and maybe even adding just a lecture inside of a course. But 2 were completely new courses. And one was this last one, kind of the capstone of the networking track, if you want to call it that, MB 4504, to design and implementation of LBC events. That has been approved by the academic council, so it's an official course on campus. It still hasn't had its first offering, though. That will happen in this next academic year that begins in October. Okay, and secondly, we have a section of 4920, advanced topics in modeling and simulation. And some of you will see that and you might think you know what it is, but you may not know. Now, I'm not sure any of us knows exactly what it's going to be. It's going to be a brand new course. So this is a recyclable number that's meant to be reused for new topics as they come along. So what this will be is kind of a bigger, better, more advanced treatment of combat modeling and other topics than students get sitting in an OR-focused combat modeling class, which they all do. Okay, and that will also be offered for the first time this next academic year. So this one is a little behind because Imra needed to be pressed into service to stay as our director for another year, more than planned, but we would expect we'll catch up on that, and all the other items are on track, so hopefully we'll look good when it comes time to finish this next cycle. The last thing I want to say is that MB 3500 is back in the rotation, so if you were here last year, I would have told you that we had kind of had that taken away from us in the interest of cost savings and reusing the CS networking class, but thanks to some efforts from Don, who instructs that course, that's now back under MOVE's control. So pressure's on us then to really make that networking track everything that it can be and ought to be to prepare students as best as possible in an academic environment for some difficult jobs they're going to see out in the field. So that is what I wanted to say, and there are questions, I will take them. Yeah, go ahead, sir.
Sir, you mentioned the artificial intelligence. I was wondering, like, what are the specific behaviors you are trying to accomplish when you approaching the instructions of artificial intelligence?
And so we have a basic course and then an advanced course.
That's one.
Yeah, in the advanced course, these years, it's been, so my goal is to talk about all the techniques I think the students might actually use if they're actually doing a thesis in the area, or we'll see from a vendor who comes up and is trying to build something great for the next generation of AI behavior. So that includes everything from finite state automata on the way basic end, right? So pretty much every simulation that supports behavior at all is going to at least have finite automata or an equivalent, or maybe a behavior tree these days, but it's not under the hood, might be a finite state automata. Onto logic-based systems, goal-based systems. Reinforcement learning is an increasingly large part of what we talk about in that class. So that's a machine learning technique where a learner hooks up to a simulation and learns by trial and error what good behavior from bad behavior. Also, game solving techniques are increasingly important. I'll say a few words about what's the real cutting edge of that, but just a few words this afternoon when I give my afternoon talk. But maybe that gives you some sense. Does that satisfy you, or do you want to follow that up?
Oh, that's good. I'll probably talk to you.
Okay, sure. Yeah, I'd be happy to. Yeah, yes, sir.
Sir, I just had a question on the curriculum. I know Admiral Rondeau mentioned like NPF Next and moves continuing to iterate and change. Would you be able to, I guess, briefly just the changes of the curriculum from last year to now this year, like the changes that are happening?
Yeah, sure.
How it differs from what we've seen before.
Okay. So there are the two new courses, right? So those are the biggest changes. There is in here somewhere some information on getting part of this block, but these were all the areas that we found some kind of a gap. So mostly what these were about was so as part of our curriculum process, the Marine Corps has a survey instrument that they send out to students, to past students, to faculty. And they try to figure out where the curriculum is doing a good job, which is great. We don't have to do anything about that. But more importantly, where are gaps? And so some gaps were identified in all these particular areas here. That's correct. 1, 2, 3, 4, 5, 6 of them on this slide. So there's more than that. Yeah, here's the rest of them. 7, 8, 9. Okay. I think maybe they got bundled into multiple groups. But these were the various areas in which it was found necessary to add more material. And I think there might, yeah, so this is our work plan here. So you can kind of see which specific courses are getting an upgrade. And I think it also gets broken down by course number down here. So these are the courses that have something new added to them, even if it's a relatively modest thing. So this is more that I want to read to you, but I think we'll incorporate it as part of the session here, and I can stand the questions to it if you want to follow that up with anything more detailed.
No, that's good, sir. I think it'd be for like us all the previous students to see kind of where we were at and where we're going. I think it would be kind of helpful just to see, because I know we've all probably, most of us have done that super long Excel sheet with the feedback. So I'd just be curious to see how much of it's getting taken and implemented.
Yeah, well, I mean, we worked from there. Some analysis was done by Courtney in the modeling simulation office to figure out where the biggest gaps were, and then we just kind of worked from that to the work plan. So it's a pretty direct line. Yeah.
Chris, is this somewhere we can access?
I don't know. Are we going to put slides up, Perry, or?
Yes, we're going to put the slides up.
Okay, so it will be available then. And if you don't find them, don't hesitate to poke me.
I'll be sending out an email to everybody who's on the Moves mailing list. So if you received an invite to this, I kind of guess you do since you're here. You should get that, and then that'll be directed where the both the videos and the slides are.
All right, thank you.
Okay. Yeah, please.
Hey,
Don's our PhD chair, for anyone who doesn't.
yeah, that's
Yep.
been moving right along. Happy report that we survived COVID just fine. And that, you know, that might sound like old news, but it was a worry because we had people coming in, some of them who were not prior moves masters, but other disciplines, and then suddenly they're adrift while we're all locked down. So everybody's getting through the pipeline. We have one or two new folks coming in. You're going to hear some illustrious PhD work here as part of the moves open house. It's typically a 3-year program. We have a well-defined plan. The instruction is all online. We're taking some lessons learned from information sciences, who has like 36 or more PhD students. So could we get bigger? Yeah, but probably faculty would be our gating factor. But we have a solid program. We have no shortage of topics. It would be, if anybody needs help figuring out why your command should send somebody, and how to get them back and how that benefits you over the long term, we're happy to help you work through that rationale.
Hey, do you see any questions, like take the Marine Corps specifically, how you know, they're figuring out how to utilize that? Do you see long-term sustainment in that PhD technical program right now? I mean, or any indication that it's going to grow or go away? From your perspective, I guess that's.
I don't see any reason why it would go away, because we're working on it anyway. And
Are you talking about the PhD program specifically?
Specifically,
yeah.
We have a Marine coming in next month.
Okay.
So, I mean, of the Marine PhDs, we seem to get a disproportionate large number, so.
Okay.
Yeah, there's no connection between the academic goals of PhD and a lot of the detail or funding rules. So we have something that works. So we're very careful to sustain that despite any challenge. So yes, we're open for business if somebody wants to work hard.
Chris, 2 questions, sir. First one, is there any discussions about bringing digital twins and the development of those into the curriculum? And then the second part is, in conversations with the sponsor, do you ever have concerns that the Project TRIPLE is going to eat the M&S officer with a high focus on training and education over analysis and experimentation?
Boy, I'd like more information from you. We're getting to the end of the hour, but yeah, so I would like to know that makes questions from my side, which are I would like to know exactly what you consider defines a digital twin, because I've seen the term used multiple ways.
That's why I was coming to the schoolhouse to figure that out. That's
yeah, I mean, certainly it had moves research projects that have also leveraged that term. I think we could do that. Like when I'm building behavior, well, shouldn't it be a digital twin for like actual behavior in the real world? I suppose it should be. I don't usually use the term though. So that's interesting. What Project TRIPLE, I don't know much about, honestly.
This is just the LVCTE. We're understanding CD&I is the sponsor, but TCOM's an adjacent 3-star. I would say 75% of the M&S officers that you produce for the Marine Corps go to Training and Education Command, and LVCTE, which is Project TRIPLE, has a large funding stream behind it. I just seeing if there's a difference beyond Chris's class, which I think is appropriate. We probably then need to extend that to the basic school and to the actual like training people who are then going to be training Marines physically with the tools that were provided. I'm just concerned that there's still the other communities of the M&S world that M&S officers at the MEFs and OAD need to be able to speak intelligently about it. So maybe I'm preemptive in getting it from a.
Yeah, I mean, I haven't seen anything worrisome along those lines yet, but you're right. A lot of things do end up following money. But then we have some inertia here, and mostly I think there's a perception, at least, I hope it's deserved, that we do good work. So people like that, so I don't want to mess up with success to too great an extent. But yeah.
I think that's a great question, and we need something to talk about during social hour.
Okay.
So good time to talk about it then. So I'm going to call it, I think Chris's time is up, so thank you very much. Okay, so good morning. Our next talk is the Dysruption game to study surprise and infrastructure management. We have Daniel Eisenburg and Elle Hancock coming from the Operations Research and Center for Infrastructure Defense. If we remember Dystopia from a long time ago, work we did for Center for Homeland Defense and Security, this is a follow-on to that. So I'm really interested in seeing this. So take it away.
Yeah. Where do I need to stand?
Okay, kind of like right here. So, you know, if you can see the camera, it's good. Otherwise, all people are seeing is the Dell monitor. So.
Hello, folks online. Hi, Dan Eisenburg. I'm an assistant professor in operations research and deputy director for our Center for Infrastructure Defense here on campus. We're joined by Elle, who will be talking about some of our initial results from some of the qualitative data that we've been collecting about this game. This is my first time talking to moves, so learning a lot from the curriculum, but also any questions or collaborations and things we'd be really interested in discussing either in the questions or after. I will be going over, so the general project that's funding this. So I should mention this is a project funded by the Strategic Environmental Research and Development Program, which is a OSD program that's a collaboration between DoD, DOE, and EPA. This is basic research to try and understand how we think about surprise and surprise management for our infrastructure systems, particularly on installations. So Center for Infrastructure Defense, we like to think about water, power, transportation, telecommunications, anything that you would consider lifelines, supply chains, those kinds of things. We develop models for that and essentially identify vulnerabilities in those systems. And the whole goal for the disruption game is to try and put those vulnerabilities in a more interactive environment and have people play and try and learn about what vulnerability means for these infrastructure systems. And the notion, I'll go into more detail about how we think about surprise, but one of the key things we're trying to understand is how folks might be able to deal with either failures or vulnerabilities that they didn't necessarily anticipate were there in the systems that they're actually managing. That kind of bottom level is kind of the three major bins for thinking about the overall project. So there's a lot more depth than I'll be going over in this short presentation, but in general, we're worried about climate change and natural disasters that might happen in the future that are of greater extreme or more frequency than what we're used to handling for our installations across CONUS and OCONUS. As was just mentioned, we're trying to do this in realistic but fictional places so we can have various groups involved in thinking about these problems, not just folks within the Navy or the DoD, but also folks in the broader community. We've been using this at Arizona State University with some of their students in civil engineering, for example. And so dystopia and kind of this fictitious island that we can move around the world is a key place for it. And the goals for novel training and exercises, which is kind of the disruption game. The reason why we're here talking about moves is because a lot of the development in terms of the actual implementation was done in collaboration with Eric Johnson's team. And so we're still in active development every year with their team and improving it. So for those who want to use the game or think about it, we'd love feedback on how to make it better. So I want to get a little bit into how we think about surprise and what we're trying to do with disruption, just to give you some background. So some of the research that we're developing is trying to identify where surprise comes from, how people think about it, and how we think about it specifically for infrastructure management. So when a pipeline breaks, how do you think about both its response to it and how you're dealing with that problem that might have created it? We've identified kind of 5 buckets or sources of surprise that we find very common in infrastructure management, especially when it comes to natural disasters and climate. So these are broad buckets. I won't get into huge details, probably the ones to make sense of, like larger variation, right? So climate change is shifting the distribution and variability. We have non-stationary climate risks we're trying to manage, and that changes the frequency of the events and the size that you might experience, which people who have a lot of historical experience might not necessarily be able to handle. That bottom left one is one that's kind of built deeply into disruption right now. So often the way that we manage our infrastructure networks are hard to understand until things start failing and you start seeing the reconfiguration and reoperation of our systems. And so there's a lot of hidden mechanisms for how they operate, even if you might have an engineering background for how you think the system should work. And so in OR, we are often identifying these vulnerabilities and talking about them in manners that we hope people can get not just practical understanding of how to identify them, but also strategies for managing them when they reveal themselves. In terms of the actual kind of gaming and and surprise process. There's kind of 3 stages that we're trying to understand in terms of the actual gameplay and folks who are using disruption. The first is kind of this notion of autonomic arousal. So like they're sensing something happened, like do they even recognize that what's going on doesn't necessarily match their models of how things should work in their head, or do they not? Right? That's a key factor to whether you will be surprised or not. So if you don't have any basic model for understanding it, you can't even be surprised by an event. There's some kind of cognitive and emotional orientation. So similar to like the surprise face that we have when we're surprised, like if you get emotionally shocked or cognitively shocked, you might not necessarily be able to respond effectively to some failure that's going on. Or equivalently, if you're able to navigate that situation, you might be able to better understand kind of why you're responding and what you're responding to. And then the last bit is actually updating your beliefs of what your model is, and hopefully in an effective way or in an ineffective way, right? Reframing, oh, this is what I thought about the likelihood of some future climate event, and this is what I should do now. You'll notice that there's kind of 2 paths through this process. One that we're loosely referring to as the adaptive one. That's the one that we want folks to be able to take. So surprise is something that we will experience. Surprise is inevitable. And so we want folks to be able to effectively adapt to it. What we tend to see and what people tend to talk about, at least for big infrastructure failures, is this other path, which we're referring to as shock. So often when a hurricane or a fire or some other tsunami, some kind of natural disaster occurs, whether it's climate or otherwise driven, it's so extreme that we end up making a lot of bad decisions and going through this process ineffectively. So really the overall training goal here, which is really long-term, is to try and make it so we can take the green versus the red path more effectively. And we've approached this kind of in this gaming environment for the first time. So operations research, I do a lot of optimization modeling, a lot of vulnerability assessment, things that might be informing modeling and simulation in general. We actually have simulation as one of the things we teach in our department as well. So those are kind of like far from the pointy end of the spear in terms of like reality, right? Where like a live event is as close to reality as you can get. You're actually experiencing the hurricane. We're trying to develop a system that allows us to try and bridge that gap a little bit more. So in particular, we can give you in my department like the math to identify this is like the worst case thing that could happen to your system. To internalize that and take action on that is actually very difficult. Putting into this disruption game changes the conversation on what that really means, and I think helps folks internalize in a more practical way what they can do about it. And so, as was mentioned, we are leveraging dystopia kind of as the background. We want this to be realistic, but not necessarily real. So we can use it with multiple different groups, not just in the DoD within one service, but across the services with foreign national officers we have here on campus, as well as other departments and other schools and other applications, right? So understanding infrastructure vulnerability for installations also applies in our communities. Dystopia, for those of you who aren't aware of it, it's kind of like this virtual place that has a lot of realism in terms of the communities and infrastructure that have been built into it over the years and many, many uses. One thing that we've been working on, though, is that the infrastructure isn't really that realistic. It doesn't have like physical information for how the power system would work if you were to run it like a real power system. And also, you can see that some of those lines are kind of going out into the middle of nowhere. It doesn't really make sense. So part of the work that we're doing is trying to develop like more realistic benchmark systems that we can be putting here to be running the game. All that you'll be seeing today is kind of the first cut, which is fictitious, but let's say less realistic, still kind of in this more cartoonish state than the like real physical models that we also develop. So that gets us to the game, Dysruption, which again, Eric Johnson and his team have been extremely helpful. They helped make this awesome picture, and I think it's great, and it's a really fun interactive thing. You can check it out right now, disruption.net, spell it with a Y, not an I, or you might run into some other website, I don't know what that is. And I wouldn't say it's very mobile friendly, but it works on a laptop or a tablet. You kind of need a big screen space for it to be really effective. And if you ever want to use it or you want to discuss it, please reach out to me and Elle and the rest of the CID team. So what does it look like? So it's got kind of it's got a UI and the UI has two specific purposes. One is to give you kind of the geographic representation of the infrastructure system we're talking about here. It's like a fictitious fuel network that would be on the size and scale of some major military installation or community. But it also has the schematic view. So one view is what we kind of experience out in the real world, and the other view is what an engineer or one-line diagram, the folks actually manage it, would be viewing. And this is, there's dotted lines, and they're actually moving and flowing. So this is a working system that actually is flowing fuel to various parts of your installation or your community. And what you can do is you can click on each of these different pipes and turn them on and off. Or as we have different gameplay that I'll get into, we turn them on and off for you. There's rerouting of flows, and that leads to different scores because you're either serving fuel or you aren't. And for example, maybe different aspects of the network might be more critical, like we need to get fuel to this part because it's a more critical mission. Can you get fuel there or not? In the background, we have a realistic kind of network flow optimization model. So this is one cool thing that we're doing here. So this is the kind of model that I'll be writing in Python in terms of utilizing kind of this AWS system that we've developed with Eric's team. We have a kind of a model engine in the background that's we can swap in and out with actual realistic physical models that we would use to represent the system. So this is a simplified network flow model. Don't worry about the math. Just know that what it means is when you lose a lot more points if you lose a customer than just like maybe sending fuel a really expensive route through your network. And so this is the same kind of mathematics and tools that you would use if you're doing power flow, water distribution, transportation, those kinds of things. We have 3 different games that we play. One's called Break It Bad. So people are given a working system. They have to turn parts off and see how much damage they could cause, which we find as an extremely useful way for people to learn how a system works. That's not often how it's taught, right? Engineers are usually taught to build system ups and just keep them running. And if it ever goes off, all hell breaks loose. Well, it turns out if you break your system, you get a much better understanding as to what's going on and what's really important. The second game that we've made is called Fix It Fast. Now we give you a broken system and your job is to turn pipes on to try and get it working with the least number of recoveries and costs overall. And so that's trying to change the perspective and show, right, what's good for fixing isn't necessarily what's good for breaking and vice versa. These are 2 different processes that are interrelated but not the same. And then the last game, which is kind of the multi-turn one that will eventually have things like climate risks, is called Save Our System. This is where we're subjecting you to failures. You're given a budget, you get to repair, replace, protect things, and your pipes are breaking and you have to keep the system running. So just some more specifics, right? You in Break It Bad, you are the attacker. I'll probably go through these pretty quickly, just because you can go play the game and we can talk about the actual workshops and how we run, and we do this in lots of different ways. But we go through kind of a series of different attacks, like what's the single worst or the 2 worst or the 3 worst attacks that you could do. And one idea is that these aren't nested. Like the single worst pipe that could fail is different from the next 2 if they were to fail together, which is something you see all the time in vulnerability assessments, but not something that's really intuitive, and it's actually hard to understand why that might be happening in a system. So it's understanding kind of this notion of vulnerability is not nested, it's not a simple list. And also we have this notion of hidden in plain sight. So it's like, in general, when you're told what the worst failure in a system is, it's really obvious, but to actually find it on your own, it's very hard. So it's like, once you know, it's like, yeah, that's the most important thing, but to try and click through our game and find it, well, you might not do it in the time limit that you're given. So we run this with a lot of different groups. In particular, we've been doing it a lot with the Civil Engineering Corps Officer School, so NAVFAC CCOs, and we have military officers kind of play the game to try and identify what these strategies are for how the system could fit. Then, as I mentioned, Fix It Fast. We give them a broken system. We see how well they can fix it. Again, they're given different budgets of how many pipes they're allowed to fix and how well they can bring the system back on. Again, the goal here is to show that the strategies kind of differ depending on which side of the coin you start on. And then for Save Our System, we've present them again with this multi-turn game where pipes are breaking, but they can repair and replace them, which give them different qualities and likelihoods of breaking. We try and make this kind of realistic, again, not necessarily real. So what you're seeing at the bottom are actual reliability curves that are common and used within the DoD. Like the blue one might be one that's used in like normal palm cycling and discussions of actual infrastructure investment. The red one is what you get because you're in the world of like increased accelerated failures. And also we tell them like, this is the likelihood of how many different pipes breaking over time. And, presenting the statistics to even folks who are experts in statistics doesn't necessarily help you make better decisions because a lot of pipes might fail and you might make bad decisions in terms of your replacements. So we give them as much information up front that they would normally have as an engineer, but that doesn't necessarily translate into well-played strategies. And we do this in many, many different scenarios. So one, it's like you have a brand new system and you just get to keep it running. Way to go. No installation we have is anything like that. The more realistic one is scenario 2. You're given a previously used system that actually has broken things and everything's a little degraded. And it's much more difficult to keep running with the same budget. And then we also have a scenario where it's like everything's failed. In fact, it's the exact same scenario from the Fix It Fast, but almost no one notices. You're given a budget enough to get the system back up running, like Congress has given you emergency management funds. And it turns out this is one where you just can't keep the system running. It kind of gets that conversation about like just injecting a bunch of money to solve a problem doesn't necessarily solve the problem. As I mentioned, we've used this a lot of times, 8 in fact, and even though kind of the first beta version of this was finished about this time last year, and a lot of those times have been with the Civil Engineering Officer Corps School. We've also used it with CHDS students here on campus for the Center for Homeland Defense and Security, and at Arizona State University and various conferences like the Military Operations Research Society. I'm going to hand it over to Elle to talk about some of the qualitative results we've been getting from these different gameplay.
Okay, good morning. Okay, so as mentioned, the game has been play tested in several settings that include active duty public works officers, civilian emergency.
Stand in front of the camera. Yeah.
Okay.
One step.
Civilian emergency management folks, operations research personnel, and undergraduate engineering students. Let's move on to the next slide. There we go. So the civil engineering officers at Seacoast are at the advanced and intermediate stages of their career. They are near to the problem, managing critical infrastructure, and have experience with system management. So what we're trying to portray at the top here is a spectrum of our cohorts that are nearer to the problem and farther away, and you will then begin to see how they respond to these experiences of surprise accordingly. So the folks at the Center for Homeland Defense and Security here at MPS are mostly civilian master's students. They are near to the problem from emergency management and disaster planning backgrounds, arenas such as police, fire, FEMA, Homeland Security, etc. They are further from daily direct system management, but are closely aligned. So we've got them set up in the middle here. Further from the problem, we have the Arizona State University students and military operations research personnel. We expect them to have some STEM background and possibly engineering training, but they're generally removed from direct management of infrastructure systems in their daily work life. So having collected feedback with each group after each game, reported experiences suggest that this platform does actually have potential to elicit surprise and responses characteristic of adaptive capacity and shock in our participants. So what I'm going to do is I'm going to take you through some of the results with each cohort using the sensing, adapting, and learning framework as previously mentioned by Dan. Okay, so here we go. So Seacoast participants. What we've got up here is some of the quotes that have come back from the feedback responses. And what we see that with this group, upon experiencing an unexpected event, they do appear to display a level of surprise at being caught off guard at their own game, in some cases leading to difficulties in assigning priorities. However, the recognition of needing to adjust strategy does come pretty quickly and does appear to be learned within that same episode. So what we suspect is that because these participants have more experience, they actually also have higher expectations of self and also of their understanding of the system. So interestingly, at this level, there actually appears to be more scope for shock when experiences don't meet these anticipated outcomes. This, as mentioned, this demographic did, however, exhibit cognitive reframing strategies that are characteristic of people with, skilled emotional management tools. So they were able to, just though they might have a delayed reaction, they were able to learn quickly to adjust their style and strategy. So although the initial reaction may potentially be negative or maladaptive, as is highlighted by the black outline around the red arrow there, they are more likely to then move over to the positive pathway and arrive at an adaptive response within the time frame. So moving on to the CHDS folks. These guys with some experience of system management relied heavily on their intuition to carry them through. And it did seem to come as a surprise when their intuition failed them in this scenario. And they would feel sometimes that their instinct was actually falling away as they went through the game. And games were described as harder than it looks. And their own knowledge was questioned as an emotional response to first experiencing this unexpected event. They felt that systems I thought I understood, I did not. And ultimately going away and thinking that perhaps their way of thinking requires some updating. So they were seeing some sort of mental model update or updating of belief systems. So although this group did not always come away with adjusted strategy, many responses did display a lot of self-reflection, needing time to think on how to approach a similar situation next time. However, others did defend their prior views, attributing maybe poor performance to, say, bad luck or lack of information, the time pressure, thus showing like no clear maladaptive or adaptive pattern within this group. We saw signs of both pathways in the middle here. Okay, so moving on to Arizona State and Moores. These participants were aware of their lack of experience from the beginning. So we did see that they displayed lower expectations of themselves by often beginning the game straight away with a trial and error strategy. As the games proceeded, they showed signs of emotionally responding to surprise by opening up to strategize under pressure. And they did ultimately find that they were learning that they were assessing their whole learning experience, realizing that critical thinking takes more time than previously expected. So conversely to the Seacoast group, at the opposite end of the spectrum, we have those with less experience and lower expectations from this lack of experience. And this is acknowledged by this group. They realize that there is a room for growth to come, and they do tend to come away with a widened lens of the problem by the end of it, on how to manage these infrastructure systems and ultimately manage surprise. And they may even be able to present novel ideas from this viewpoint to more experienced system operators because of this sort of ability to step away from the problem and remove themselves maybe from prior experiences that others have. However, despite less tendency to experience shock, clear learned adaptive capacity during the game is not as evident. So we see they maybe have a more positive reaction to the surprise at first. They don't have as much scope for shock. They realize they have room for growth. And then, although their lens is widening, they don't have as much learned adaptive capacity at this point to apply a problem maybe within this scenario at that point in time. So in summary, Dysruption has shown us that game-based exercise is often an affordable, quick, and cost-effective platform on which to test strategies for surprise training. We have found that experience and infrastructure correlate to positive and negative differences in behavioral responses to surprise across the cohorts. And adaptive and shock responses can occur during different surprise processes. So with that, I will hand it back to you, Dan, if there's anything you want to add or talk about next steps.
Sure. I guess just to summarize, kind kind of this overall project is an integration of some of the techniques we have in operations research for vulnerability assessment, some of the work here in moves in terms of interactive gaming, and some of the new types of like qualitative research that we're trying to lead in terms of understanding surprise and management. We do have some active student theses, so future stuff that we're going to do is trying to incorporate wildfires as one particular climate-driven threat, and also specifically focus on power systems. We have a student developing kind of open, ideally distro-way benchmark power systems that represent installation level infrastructure that don't exist out in the public world, but we need for design and playing these games. And we hope to maybe take this to the next level in terms of the qualitative research, right? So a lot of these responses are mostly in terms of the game development and less about actually trying to do data analysis. So we want to move into this space where maybe we can actually collect a sufficient amount of responses to get a better understanding of surprise in our infrastructure for the Navy and the DoD in general. All right. Any questions you have or thoughts, we'd appreciate it. Again, this is one part of a larger project, so we could also go into more about surprise or climate risks or all sorts of other things, but we can also talk about at the break. Thank you so much. Yeah.
Daniel, thanks for that. You talked about surprise related to infrastructure, but
Yeah.
could this surprise model be applied to other contexts besides infrastructure?
So the general stages and processes of surprise, it's actually like kind of leading all the way back to like intelligence community research from like the 70s and 60s, which was more about surprise attacks. And so it's the same notions of surprise, whether it's from intel information and making some kind of military decision as it would be for infrastructure. Part of the novelty here is actually applying it in the infrastructure space where it hasn't been discussed in that way. But the general framing, yes. The overall structure of disruption maybe wouldn't really work in anything that wasn't some kind of networked system, right? So all of our infrastructure are considered networks. If there was a social network or something that you wanted to put on a map, that could apply, I guess. But the things that we're really focused on are essentially lifeline infrastructure.
I was thinking like tactical surprise, right? You had an operation going on, you thought all was going to go well, and suddenly, as everything else happens at war, right? There's a tactical surprise. How do you handle that?
So exactly, the point of the theory and the approach, I think, applies in that space. The implementation and the things that we're doing, it's very infrastructure focused. We would, if someone else wanted to lead on that, we would love to, support in some way. Yeah.
So your previous slides where you were talking about the results, did you do any kind of temporal analysis from like how long it took to move between sensing, anticipating, and learning? Did you look at
no? So like, yeah, these are
your experienced people quicker to get to, to transition versus your, the near versus the far?
Yeah. So to qualify these results, right? We would say these are kind of an interpretation of responses to feedback forms that people are giving both during and after gameplay at these kind of 3-hour-ish workshops where we go through all of these different games, some of which are more like trainings for like the Seacoast folks, and some of which are more like workshops for the ASU folks. And so we're not doing very detailed human factors types of analyses, anything that a lot of folks in this room might be able to offer. But that's that kind of last bullet point on the summary. It's like that's one direction we hope to go. In fact, any feedback or discussions about how we could be updating the game to better inform those kinds of things. So one thing that we do intend to do is collect more information about all the clicks, which pipes people are turning off and on, for example. So to match someone saying, I just tried stuff to see if it works, to see if they were kind of equivalent to randomly clicking. And someone who says, I got a strategy, and see if they're equivalent to randomly clicking, to make sure that there's a match between what people think they're experiencing and what they're actually doing. But we're still in that kind of earlier stage.
In the one case where you had a limited time, how did you enforce that time limitation? And did you try different strategies for limiting that time?
So
like white noise gets louder and louder in the background. Just
No, it's so there's a big timer at the top, and the second it hits 0, whatever you have selected just gets input as your options.
Okay, so it's sort of self-motivated.
Yeah, and we give them several opportunities before we put a time, like we kind of slowly build them up to it.
Sure.
But the game is kind of inherently designed to be somewhat difficult to play. So for example, you don't get to click on multiple pipes and turn them all off at the same time. You have to turn off each one individually, which forces people to do systems thinking. Because it's like, if you don't know your strategy before you start turning pipes on and you start doing it like one by one, you will end up with the wrong solution. And you won't do it in time, kind of thing. So there's kind of both gameplay elements as well as a direct, like, implemented timer that will just take your solution. But no sound effects. This game only is visual and I guess tactile, if you want to think of it.
With the previous 2 games, the Break It Bad and Fix It Fast, we did also try implementing a time limit with me there with my watch, and trying different amount of times and seeing how people were just observing, looking how people were reacting in the room. So I was the sound at one point. Yeah.
Brilliant.
Thank you.
Well, thank you. That's all the time for questions we have. But thank you very much. Hopefully we come to the social hour tonight and hopefully I answer some more, or I could demo night tonight or some of the other breaks. People can ask questions if they have them. But thank you very much.
Thank you.
Our next speakers are going to be talking about Chain Agent. Like our previous speakers, it's also a game that was created by our future tech team. They do an awful lot of work for not only moves, but a lot of other places on campus. And so this is one talking about changing mind and behaviors was the purpose of this game. So Deborah Gibbons and Heine are going to brief this one together. So I'll turn it over to Deborah.
Good morning. So we're head team in here. I'm going to talk about the concepts and the reason behind developing this game. And then Eric is going to jump in and talk about how it actually works and what's under the hood a little bit. And so, no.
You have to click the screen once and then the arrows will go.
Oh, thank you.
That was my screen.
You figured that out. Okay, great. So my expertise is in organizational analysis, organizational change, leadership, behavior, social psychology. And that is background to this game because this game is about shaping behaviors in organizations or shaping attitudes in organizations. And it's also meant to extend eventually to peacekeeping environments where you might be shaping attitudes and behaviors in the population you're working with. And from there to environments in information management, where you're trying to get your ideas adopted rather than somebody else's ideas being adopted in a local population. So our initial work on this has been more within an organization, but the principles of social influence are the same in any social environment. So even though we're talking mostly within an organization now, we do have it on the board for the future to put it more out in the population. All right, so change is hard, right? And sitting in the Department of Defense, I've been here 19 years. Some of you, maybe not that long, some of you maybe longer. We find that there are a lot of top-down efforts at changing stuff. You get a new boss, you get a new directive, right? There's a lot of forced training, right? Okay, we want to get people to think in a new way. Let's set up a training and they can click through a PowerPoint. That's not the way it ought to be done, right? So it's hard to bring a true change in an organization. It's not like changing the furniture. If we've got people to think differently or to do things differently, to adopt a new technology. One of the background reasons for developing this game was about mainstreaming women in peacekeeping operations, right? It's a completely different way of thinking about things. And if we want people to think about things in a new way, If we want them to adopt a new thing, then we need to get into the grassroots. We need to get into managing the social networks and working with the social system. So, thanks to Ryan, this is a thank you. We'll be on to our video here. Oh, yeah. Okay. And Perry, how do I tell it? Share the sound.
I thought there was sound this morning. Let me come up and take a look.
Yeah.
Oh, it's half sound. So let me.
Definitely need sound. So while he works on that, let me talk for another minute. This game has been tried out in a couple of workshops for peacekeepers in Latin America. It's been tried out in a couple of classrooms here at NPS in my classes on organizational analysis. And we are hoping to then make a few refinements and start building it into regular practice in both venues. So the workshops are about integration of women in peacekeeping. The class here is about analyzing organizations and bringing the change that you would like to see happen. You know, in Zoom, if we're going through Zoom, you have to tell it in Zoom to share computer sound.
It's the same one. I have something for heads. Yeah, I think when I set this up, I said to use sound on Zoom, but it should be hitting it somewhere else.
Share sound.
It just doesn't seem to be coming out of the computer, which is the. Let's try this now. Turn what off?
Did you turn this off?
I did, but yeah, that's true. It might be the only one. Thank you. I thought it'd be the only speaker this computer has.
Headsets in Zoom, you might get echo.
To celebrate our success and acknowledge the challenges we overcome. Despite missing our projections last week, we are still on track to achieve our KPIs and drive profit. We have leveraged our thought leadership and adopted a customer-centered approach that has enabled us to differentiate ourselves in the market and drive incremental growth. Our employees are the backbone of our success. With your dedication and hard work, we have been able to pivot our strategy. Moving forward, we will continue to leverage our core competencies.
Really? Change is hard. Building support for it will take a lot more than brute force. We need smart, strategic leadership to ignite change and forge breakthroughs. Introducing Change Agent, the game from Global Echo that lets you try out different social strategies to enact change that works. Expand your social capital. Empower your allies. Recruit influencers to champion your ideas. Shape the social structure to bring the change you want and get more people to buy in. Change Agent features office, military, and peacekeeping settings. Change Agent. Influence, innovate, change your world.
There you go.
So, Great. So, we've built this game to mimic the real world in some very important aspects of social dynamics and change. So we have social networks that, this is not from the game, the pictures in the video were from the game. We have social networks that connect people in an informal organization that sort of reflects the formal structure, because that's how it is in the real world, right? But people can build new ties to friends and friends of friends, and information travel through the ties. So key concepts that are built into here. We need to work with the formal structures and the informal structures, and hopefully use the formal structures that we've got to help us work better with the informal structures in our social system, right? We know that informal networks, they carry emotion, they carry sense making, and when we're innovating, when we're trying to change attitudes, when we're trying to win hearts and minds, it's the emotion, the sense making, at least as much as the function that is supporting diffusion. So, you know, the old diffusion models talked about characteristics of the product and then the social influences, right? And in some situations, the product may be a little more heavily weighted. In some instances, the social influence and the emotion are more heavily weighted, right? So we want people to be thinking about how do we carry the emotions, the ideas, the impact, and that's through the informal structures. So the bottom point here, strategic use of social networks can increase our ability to get things to diffuse and get them adopted. So we want to work on that, and that's what Change Agent is really about. So some learning points when we're using these in a classroom. Be sure people understand social capital, what it means to be building social capital, ways to build social capital. So it's not just my relationship with you, but it's my relationship with different people who are in different parts of the network, right? Because then I become a boundary spanner, I become a gatekeeper. It's also about finding people who have influence in their setting, right? And getting to know them. So now I can recruit them to be change agents and they're part of the network. So the lessons that undergird this game, a lot of them can be picked up through the gameplay, although there's always an intro of about a half hour to hit some key points for people to work on and watch for. But I prefer to actually have a session before the game that gets at some key aspects about developing our social capital. So a couple of example activities that we've used before this game in a workshop setting where we have multiple sessions. Then we give people a project that they pick a project, pick a topic that's related to what we're doing. So in the women, peace and security zone, it would be think of an issue about integrating women. Who are your stakeholders? How are you going to influence them? How are you going to reach out to them through social connections? How are you going to do your messaging? So have this in the background before they play the game. This kind of a discussion always precedes the game, being sure they understand when you're looking at a social network, like that little picture there, you know, the little squares are people, the lines are connections, and to ask some questions. When you look at that network, can you find the gatekeepers? And I think you all in this room, you can, right? Those bridging positions, those black squares, those are all gatekeepers between different parts of the system. So we talk with the participants about finding gatekeepers, about finding central people, about understanding the general structure of a network. Then we just jump them right into the game. We have a couple different ways to play the game right now. We have the gender integration scenario, which the initial thinking was this would be if you have separate teams in separate worlds, and they're each playing sort of to get their ideas accepted through the system. We also have technology adoption where you are competing. So I have a technology I want to get adopted, you have a different one. And so your team and my team are playing in the game each of us trying to get the people in the same organization to buy into our ideas. Okay. Scoring. Two main scores here. One is how many people like your idea. The other one is how many of them are satisfied with you. And we have elements in the game. If you make them do training too much, for example, they don't like you anymore, right? There are things you can do to diminish the respect you hold as a change agent, as well as using the network wisely. You need to get your network in order, right? Like trying to get the right connections and all early so the network works for you while you're then doing other stuff. So this is an introductory screen from a class, talking to them a little bit about what we're doing. These are the tips to give them. Think about strategic network development, right? How are you going to build out your relationships? How can you use formal structures like committee memberships or focus groups or coffee and donuts to get people to talk to each other, right? That you want to have talking to each other. So how can you build those attractors into the system? And in the game, it's implemented as committees and focus groups that you can invite people to get them talking. Right, so we coach them, use your formal mechanisms smartly and don't overuse them. And I think Eric's going to talk more about the details, so I'm not going to delay on this. And then find your informal influencers and really get that network working for you instead of against you. After we play the game, we go through a debrief process because that's where the learning is solidified, right? What did a high-performing team use as their strategy? And this isn't just what you do, but in what order, right? So how much time do you invest trying to build connections? How much time do you invest in sending out happy messages across the organization? What order do you do these things in? So we debrief, asking how did they work with the informal network? Somebody who performed really well, we compare that with, okay, somebody who bombed, how did yours go? What did you do? And the bottom line is, what can we take away from this to the real world? And the last question, how can we apply it in what we're doing with idea and technology and innovation in the Department of Defense? And now I'd like to hand off to Eric.
I think I'm a different set of slides.
You are. It should be the next, that one right there should be yours.
Yeah, okay. Okay, cool. So I'm Eric Heine. I'm one of the developers of the Future Tech team. Like people have been saying, we've been working on a lot of serious games for different organizations. I think all of them are to help bolster ideas and bolster teaching, to kind of reinforce it and, I don't know, more experience the lessons so that they stick a little better. So have the typical agenda slide, just sort of walking through the technical details of how was this game made technically, taking Deborah's original game design, which I was very thankful we got. We don't always get an actual game design document, just sort of I'd like a game to do this. So taking that design and adapting it to make sure it fits what we need, what we do and what the class needs and all that. And then concerns that popped up as we're developing, and then discussion. So it's built using a Unity WebGL client because we knew that there was a network that we needed to do, and we've done in previous games our two main, sorry, I'm flustered. Our two main technologies that we primarily use are JavaScript using Angular and Node and Unity. And we had done a previous project with networks using Angular and found that it's pretty, but it's difficult to really control. And we knew that the network here was something that we wanted control of. And Unity also lets you do some fancy graphical tricks of making a 3D project or 3D visuals in a 2D form. The server that it's talking to is using Node.js with a database of sorts that's sort of in memory in the server, and then using WebSockets to communicate between the two. So the game itself, you start with a network of people, an organizational network. The blue lines are the formal network. Orange lines are the informal relationships between people. You start with you, which is just the one labeled you, with any connections, any relationships that that player has with the adjacent people. So basically you're coming into this with what would you in the organization know, who do you already have connections with, and the sphere above the head is your attitude towards your idea, which is 100% you're happy with your own idea, because that would be weird otherwise. The goal of the game is to get the entire get as much of the organization on board with your idea, hopefully also satisfied with you and not hating you because you just did training. You have a fixed number of actions to perform. Each action is one turn. So after that many turns, whether it's single player or multiplayer, you see what is your overall percentage of how much of percentage of the organization did you get on board with you, and how much is opposed to you. And this game is a little less like some of our other ones about specifically winning and losing. It's more to generate the discussion of what did you do, because it is possible to have the whole organization 100% on board with your idea, but they hate you. And is that better or worse than an organization where they are mostly on board with your idea and they still like you? So you might still be part of the organization afterwards. So we came into this knowing we had a formal network and an informal network. We originally were thinking of having the informal or the formal network displayed on a different visuals, sort of like you normally see in an organizational hierarchy chart. But then we realized that we could just combine positioning the network physically and that organization chart itself. So the person in the center of this whole circle of people is always the head of the organization. That's how it's generated every time. The ones right around them are the head of various departments. And we have some flexibility to go how big a network or how big an organization it is. This is a medium-sized one, so you get 3 departments, 3 department heads, 1 head of the organization. And then everyone branching off from the department heads is a department. From there, with the original positions of everyone, we wanted to randomly generate the informal networks. And it both makes sense that you're going to form informal relationships with the people in your own department. And it just was a little easier we have their actual physical positions. And so the closer they are physically, the more likely they are to have informal relationships, was how we coded it. And it just kind of plays out pretty well. The list of actions that Deborah gave us all boiled down to basically impacting the game in one of 3 ways. There are actions that help you discover the network. So when you start off, you know very little about, you don't know how anyone feels about your idea. It's randomly generated and populated based on some settings of who's for it, who's against it, but you have no idea. You also don't know any of the informal network relationships in the network, aside from ones that are your person's connections. So we have things like get acquainted. So you can pick a specific person and you talk to them, get acquainted, and you will immediately know what their attitude is towards your idea, and you'll get to know all their informal relationships around them. It's a very focused action. There's also a survey the whole organization where you have a random chance of getting information about everyone. or their attitudes, not their relationships. So it's kind of a balancing act of trying to figure out, do you deep dive into part of the network, or do you try to start off and get a general idea of things? Other actions are actually affecting the attitude and satisfaction of different people. These are things like recruiting someone to help. If someone is already mostly on board or very on board with your idea, you can recruit them to influence everyone around them. Their own attitude and satisfaction is going to go up a great deal because you're asking for their help and they feel good about that. And then everyone around them will have an attitude and satisfaction increase as well. And then there are actions that help you actually manipulate the informal relationships, such as forming a committee or facilitating a discussion group. And this helps, aside from the player's actions, there's also a sort of network heartbeat, if you will, of once you take a turn, or once everyone takes a turn, then the network itself kind of adjusts and everyone's attitudes kind of average out and influence each other's. So if there are strong opinions, they're going to influence each other, their neighbors. So if you can create some of these relationships, you can help control that flow and that update. We also knew that we wanted to make it very customizable for both Deborah's class for all the reasons, for all the different use cases she has, but also Global Echo was the organization that we made this through. And they, Nate Christensen, he has a lot of ideas of how it could be used. So having different settings, office, military, peacekeeping, having different ideas you're trying to promote, whether if you're in multiplayer, whether the ideas are competing or not, and the distribution of attitudes and people for you from the get-go, size of the organization, all that. We also wanted the visual style to be accessible so that it'd be interesting to look at right off the bat. So Ryan has made these adorable little cube people. We also wanted it to make it very customizable so that if you play again and again, you'll keep seeing different people. So he can go into better detail, but you have different outfits that are randomly generated hair, and it's different based on the setting. So in the military one, you will or won't have a hat as one, or a helmet as one option, but then you might have a different rank, as well as skin color. So some of the concerns while making it, just in general, serious games, you try to find the balance between something that's too realistic, where that network graph is intimidating, and if I have no idea what I'm doing, I already don't like what I'm scared. Or you go way too gamey and you get Mario Teaches Typing, where the best you could do is 10 words per minute because you type a letter every time one of those blocks goes over your head, which does not teach you typing. We're also trying to keep the complexity to a minimum in the game itself. The original design had talk of random events happening just to disrupt, and halfway through, maybe someone new comes into the organization, or maybe someone leaves. And we wanted to make sure that, because of other games we've made, try to keep it simple and try to keep it playable. So thinking about what that added to the game, as what choices the player could make from that, it seemed like it wasn't very additive. So we cut that. Whereas that network update seemed very important to have the network itself regulate. And so the player would take an action and then the network itself would update. But we also wanted to keep that reasonable and controlled so that the player doesn't, the player still has a feeling that they're making a change, and it's not just overwhelmed by this thing they can't understand behind the scenes. And that kind of leads into, we also are trying to keep the visuals from showing too much information, like World of Warcraft, where it's just overwhelming, or have buried information, or you have too many menus that you have to dig deep, or too many windows popping up. And so we're trying to find the balance where we show just enough information so you can make intelligent choices, but not make it too hard to find them. And then while we were testing, if this was one of the bug that took the server down was one that I don't think ever would have come out during our testing individually, because we had a bug where the WebSocket connection would disconnect. And when that happened, the next time that player tried to make an action, it took the whole server down. And when testing the game, it's a very quick 5-10 minute, let me play this game very quick. I'm very quick, so the WebSocket is going to stay connected. Whereas in the actual class, it's teams that are working together, talking, taking time to take their action. So there's a lot more time, and the WebSocket times out. And then just the last thing is something that is too easy in a game design to get sucked into is just fun, silly things. So I was in charge of the name generation, and I tried to find the most accurate, most popular 100 male names, 100 female names, and most common last names, and randomly generate it. And you get some very interesting combinations sometimes. These are just random ones that I found while making this presentation.
Barry Whitehead is really random.
Yeah,
okay.
Exactly. So.
Okay, well, thanks, Eric. That was great. And Deborah, I think we have time for 1 or 2 quick questions.
Yeah, so one thing I've noticed in terms of implementing change in organization that's difficult is personnel change out. So does that, I mean, I'm obviously you have to bound what you're looking at.
Yeah.
But I think that'd be interesting in terms of implementation of what happens when people change out within that organization.
Yeah, so that's that random event thing. It definitely would add to some discussion. I think we chose, at least for this phase of the game, not to do it just because it was too complicated to, trying to figure out how to word this. We were trying to focus it on a short time span is your 20 turns or whatever, so you wouldn't have a lot of turnaround, because it's hard for a player to, like, if that's a random event, then the player can't predict it, and so you could have this whole strategy, and then now a random event has ruined everything, and oftentimes what happens is the players will then, if they lose because of that, will blame the game and not really learn, I guess, what they typically would, or what we want them to, I guess.
One more. Yeah.
It's kind of about networking, right? And so there's some biases I think people have that extroverts are better networkers than introverts, but I think most of us that have been around, you can see that introverts can be very effective networkers, sometimes in maybe more depth ways. Have you seen any trends to that in the debriefs about what tends to work, or because it's through this computer programming, you can't really say?
You can, because I've done these live where I'm standing there in the room. Well, I've also done one with an online class, but I've done them live in the room, and it comes down to the strategy. So for a game like this, it isn't so much about, are you a great schmoozer who's going to twirl around the room shaking hands? Because this is about thinking in what order do I build what kinds of ties so that the network will work for me while I'm not thinking about the next thing. Right. And so I think we have a good point there that getting people to be more strategic is going to help the introvert to step up and say, okay, I can do this because I'm going to be thoughtful about how I do it. I don't have to go to everybody else.
Okay, well, great. Thank you very much, Deborah. Eric, Jim Jablonski, who's the director of the TRAC-MTRY. You're going to kind of explain, I think, some of the changes on what the T, at least in TRAC, means now compared to what it used to mean, and how it's changed and what they do here. TRAC and MOVES have had a long relationship for many, many years, and that's one of the reasons why TRAC is located just below us on campus here. So they're on the first deck of Watkins Hall Annex, and we're on the second deck. So it helps us work together, and we have quite a bit, and hopefully that will keep going in the future. Cool.
All right, well, thanks. Appreciate your time, and I'll try to make this quick and then leave some time for questions, because we'll go through several projects and then talk about our research approach for the next year for the rest of 2023. And so you can see what we're focused on. And then I'll be followed by Major Kurt Reynolds, who will deep dive into a specific project that he worked with Emory Blue on over the last year. So anyway, so TRAC Monterey, if you all are familiar with what TRAC is, it's a operations research or ORSA organization, so research heavy organization in the Army. So for those not too familiar, ORSA is informed decision making, right? So that's the role of the systems analyst or the ORSA position. And so TRAC in general informs some of the Army's major modernization decisions. So they'll do things like analysis of alternatives. They'll look at other force structure changes or answer any other study questions usually associated with modernization. So there are 4 centers. We are the westmost center, TRAC Monterey, and then moving east, there is a center in White Sands, New Mexico, and they focus on analysis generally at the brigade and below level, and they also do a lot of heavy fires analysis there. Moving a little bit further east is TRAC Fliven or TRAC Leavenworth, which is where the headquarters is, as well as a cell that generally focuses on the operational or higher than that tactical level of war, brigade level of war, so division and above analysis there. And then on the East Coast, there's a small center similar in size to TRAC Monterey, because as you can see, we're not very many people, and they focus primarily on sustainment. So what does TRAC Monterey do? Our mission is really to do the research for TRAC. So we develop new methods and models and tools, and you can see why it makes sense for us to be where we are when you understand that mission. So before we get a little bit more into our mission and what our goals for the next year, I'll just talk a little bit about our people. So we do have just an excellent small team. It makes my job easy. I love the fact that we've got such high caliber people. It helps that it's in such good location. So desirable location for TRAC employees to want to go, or for our military organization. So we're only one of two of the TRAC centers are military led. And so I'm the director here. I have a deputy, Dr. Brian Wade, who is also the former director here. But so he has quite a bit of experience, and is especially experience partnering with the MOVES organization here. And then my analysts really have a diverse set of backgrounds, all highly technically skilled, and the real talent that they have is kind of bringing research, bringing practical problems to the university here. So practical Army problems, practical TRAC problems, et cetera, because we don't only work for TRAC in this capacity, we kind of work for the larger Army. So we will often find Army problems, and some examples that you'll see later on involve some of the COCOMs. And we'll find larger Army problems and bring them to the university. So there can be some, in many cases, relevant research that directly informs the mission that's ongoing. And our analysts can serve to act as liaison and make sure that the project stays on track, but that it's also appropriately scoped for a student in their particular situation. Okay, so here's our charter. And really, we're not, our research is novel, I would say, to the Army, but I would not say that we're generating new models very often and things like that. Our research is very applied. So we are applying things that are relevant in current, so some of our more recent research with large language models, et cetera, we are applying techniques that have been developed outside of the Army to Army problems. And you'll see a little bit more of that later, but you can see that our tasks are supporting this mission, are providing that methods, models, and tools to TRAC, but also that, as mentioned before, bringing mutually relevant research here through many DoD partnerships that we have. But key to being able to do all these things with such a small organization is still that partnership with NPS, USMA, and we have partnerships with Georgia Tech and a few other organizations as well, or institutions as well. To drive that innovation, because we need student support, we need professor support in order to do enough to actually be relevant. And so that being said, we'll move on. Does anybody have any questions before I go on? But okay, so this kind of gets at what I was just mentioning just a second ago, is that TRAC Monterey kind of can act as a liaison between the DoD, Army Futures Command, and NPS most of the time, but other research or other schools and research organizations, and we work to build combined student and faculty research. Okay, All right, so our 2023 lines of effort. So what we took to do using our director's guidance was to develop some tangible end state goals for 2023. And so we have 3 main lines of effort for TRAC-MTRY. And the first is really traditional ORSA stuff. So operations, research, systems analysis. So that's data analytics, visualization, and engineering, or DAVE. So in our DAVE LOE, we're really supporting current ongoing TRAC operations, sometimes with unique and innovative visualizations that support analysis of alternatives and trade space particularly. That's something that as the Army, we know we move forward, we've got so many choices, so many things that we want to buy, but we need to learn how to make meaningful trades and understand how to prioritize our purchases and what we spend on the upcoming costs. So we spend a lot on those, a lot of time on those. Another big project is our analytical support to persistent experimentation, which if you've heard of the experiment Project Convergence, the name of that has now converted to persistent experimentation, where it's AFC's intent to look at all the different experimentation or things that previously were just considered exercises and treat those as experiments. So for instance, your war fighters, et cetera, and to try to understand what lessons learned we can extract from those for modernization. So that's kind of this concept of persistent experimentation. And so now there was Project Convergence, but this is now going to be a capstone where there's a major exercise every 2 years or 18 months, it's not quite decided yet, where the Army pulls together a joint as well as many other research or many other components from private sector to try to experiment with usually pretty innovative new technologies. And so TRAC-MTRY supports this almost directly in a number of ways, but really our the contribution that we have there is our ability to process a lot of data and also to handle things to give at least some idea of what's going on in real time. And so we do what's called in-stride analysis for that, which can inform those answers that the generals want, like the day after. And then another major project we have there is called the Army Continuum of Analysis, which is now changing into the Army support to the Army Analytics Directorate or an Army Analysis Directorate. But Army Continuum Analysis was kind of a homegrown effort among a wide variety of Army analytical organizations who sought to at least deconflict and synchronize their analytical efforts, because we started to realize people were doing war games on the same things just a month later. And so what we would do is combine efforts, and this was just due to the hierarchy and just the massive size of the Army. So that was a great synchronization effort that TRAC-MTRY led the database building and information sharing side of that. So moving on, our second LOE is Army Foundational Models, and this year we're focusing on language models. So have you all ever heard of Hugging Face, the hub for large language? Now there's a lot of other models, but we primarily look to it for our language modeling, whether they're large language models or but what we're trying to do is build a similar hub for the Army. So a place where you can store trained models that are specific to Army solutions. So for instance, right now we are fine-tuning a large language model with, and this is very similar to like your GPT, TRAC-GPT, et cetera, or ChatGPT. And we're fine-tuning it to work well at understanding and giving answers for Army doctrine or any sort of military doctrine. So we've trained it on a corpus of joint and Army doctrine, and now compared its performance at answering questions about doctrine compared to like a canned model. And so what we're doing is fine-tuning these very large, very good logical inference engines that are large language models, like I'm sure you've played with or heard of in ChatGPT, and making them specific to military problems. And then we can take those pre-trained models and hang them on this hub for anybody in the military to use. And then also we have, using the data science environment that's led by Army Futures Command, we're able to hang up some of these models and give them and use them for direct access at solving problems or military problems. And so that's a big effort that we have over the coming years. So we have our first prototype of a TRAC-GPT or a TRAC-trained large language model, a custom-tuned large language model that was hot off the presses yesterday. And that's one of our goals for the end of this year, is to employ that on an actual military problem, instead of just kind of checking to see whether it's better at reproducing doctrine. And the third LOE is probably most relevant to moves, but a big focus of ours is to advance models and simulations. And so really, we recognize as technology advances faster and faster, some of the ways that we model our Army capabilities and try to understand and evaluate them to make purchasing decisions and or other modernization decisions is just not going to cut it for the future and how quickly technology evolves. And so some of our goals are to enable more widespread experimentation and covering a larger measurement space by using high performance computing and cloud computing resources, which is an effort that Kurt actually leads up as well. But then also a key to enabling simulations to work, and I'm sure you guys understand this problem, but a key is speeding up integration. Because developing a scenario is pretty challenging, especially when you want to incorporate enough data, relevant data, to make it realistic enough to make decisions off of. So one way that you can speed that up is to make the agents more intelligent, so you're not scripting their behavior. And so Lieutenant Colonel Scotty Black, also, I think you probably have presented on this already, or some parts of this, or you will. But yeah, this is a major project. So we're working with Scotty as well on hierarchical machine learning. But we're also looking at training individual agents and multi-agent scenarios in actual TRAC models. So we'll talk about that in a little bit as well. Does anybody have any questions before I go on? Sure.
So any linkage between LOE 2 and 3 in terms of being able to generate scenarios with large language models?
So that's a great question. Right now, we aren't experimenting with that particular avenue, but I know that the AI2C, is working particularly on a large language model type solution that develops orders, and so that you could see how that might translate. I also think that these fine-tuned models for Army doctrine could easily be then instruction tuned to do something like you're talking about. I mean, easily is not necessarily, but you know, it is possible. I think that there are some inherent challenges. The first being that most of these models are not multimodal, so they don't have a good understanding of spatial relationships between objects, and so a lot of what they answer in that field, except for like a model like GPT-4, which is instruction tuned, which is multimodal and instruction tuned to use a image input as well, just doesn't really have a good enough understanding of spatial relationships to say give it a map or say evaluate this scenario or draw a new scenario. But I think that in the future, that will probably happen pretty quickly, as we know that GPT-4 is multimodal. I do not see any current open source equivalents to that, but once there are, I think that would be a great project for any Army organization to kind of start pursuing.
Going back to what I think was the top item, Dave, and you're pointed to Project Convergence, which is now being referred to as persistent experimentation, and a timeline of 18 to 24 months, sort of where the Army will come together in a large scale exercise or experimentation effort. How do you think that will pace what seems to be a pretty disruptive, if not revolutionary, adoption of change in what's been observed in Ukraine just in the last 15 months? So, I mean, culturally, the Army or the Navy, the Joint Forces experimenting at 18-month intervals, but the real world is unfolding, you know, snap the chalk line at 15-month intervals. Do you think that we could actually experiment with the kind of change that you could observe or would assess has happened in the Ukraine in the last 15 months? And do we need to be able to?
Yeah, I mean, I think it's a great question and a discussion that I don't think I should answer yes or no about whether the Army can or would, but my opinion is that, I think it's always going to be extremely challenging to keep up with technology. But of course, But then at the same time, we don't want to be chasing our tails. So does it make sense just because something worked or didn't work in Ukraine for us to retool our entire military because of that? So that's a good question. I think there are tons of lessons learned that we should be gathering, but that's the reason why the term has kind of changed from Project Convergence or some sort of only event that only occurs in this periodic interval to something that is looking at trying this persistent experimentation approach, where we can say, what are the lessons learned from these small experiments that are ongoing pretty much constantly? If you looked at all the exercises that we do, in many cases, they are integrating new mission command systems or other capabilities to see what they can or can't add to our workforce. So, or our combat capability, really. So, but anyway, yeah, does anybody have any other questions? Because I think that those are great questions. And also it is our dream with being able to kind of combine LOE 2 and 3, I think is something that if we can do that, that would be great. But we know I think right now the technology really isn't there yet. So I'll start going through some individual projects, and we'll talk a little bit about those and fill up a little bit more of the time, and then leave a few minutes for Kurt to get set up before he needs to go. Okay, so this slide outlines our Project Convergence in-stride analysis, and the innovation that we brought this year, or to PC 22 before it kind of changed over into persistent experimentation, was actually using large language models. These were not fine-tuned, but they were open source language models that we moved directly onto SIPR, so they're not touching the outside world at all, but we could use those for inference to take large corpuses or large amounts of information, summarize that information, classify it, sort it, and give people better access to that data and a better understanding of what happened on a day-to-day basis. So we also used, in addition to large language models, just transformer type models, or models that essentially enable you to move a unstructured text into a multidimensional space that then you can map out and understand where that information sits, so you can rapidly find related information. And so that's just as important, and normally sits in the backbone of a really good large language model. Will have some sort of vector database that can access data and verify the answers that it's going to give you back. Rather than just like if I'm sure you've heard of hallucinations and other errors that occur on something like ChatGPT. Having this sort of vector database that can have a backbone to it is something that's pretty important as well. And so as we move forward to persistent experimentation and the next capstone event, we're looking to combine both elements so that we can have a large language model that's putting together a lot of information from disparate sources, but then also reference those original comments and sources of data from the experiment back to where they came from, to make sure they're grounded in reality, which is a key way to use these models as you move forward. The ACA dashboard, I won't spend too much time on this, except to say that more recent innovations also involve using semantic search and other techniques, language modeling techniques that enable you to look through the thousands of ongoing studies and find things that are related and data that's related that you may not have even realized. For instance, we search for recruiting or retention, and when you just do a keyword search, you kind of find just words or documents that specifically say those things. But if you use semantic search techniques, you can find related topics that will help the Army advance what it needs, and those individuals who are trying to conduct meta-analysis to be able to better discover information. So another key project that we're working on in support of experimentation as well as our research is diarization. So we have many projects that involve TTXs and war games, and also just soliciting expert opinion where you have expert discussions. And it's important to just be able to capture that accurately. And so one thing that we're using are modern techniques like Whisper, et cetera, that can listen to an audio recording, identify speakers by their voices. So speaker 1, 2, then we can label those subsequently, and then put those into a large language model tool chain to actually summarize a conversation, and then also point people to the right locations in a given conversation to get information they're looking for. So we can make searchable databases of experiments that we've done just based on audio files. And I think it's a pretty important thing that we're working on over the next year. Trade space analysis. We are looking into visualizing the trade space in order to help understand the balance, particularly in this case, between cost, performance, and schedule as the Army makes acquisition decisions. This project, Kurt could answer a lot more questions on this, but we actually have built a custom model using what's the backbone in R that you?
SIMR.
SIMR. So a simulation to help CENTCOM actually conduct non-combatant evacuations. So estimate the resources required and optimize where they put their ingress and egress points in order to optimize a NEO operation. And the cool thing about this project is it's also, we started with building the base of the simulation, but then now we've passed that off to student capstones and other student project work where they're building out the capabilities and working specific problems, and they're doing it hand in hand with CENTCOM and really kind of informing that stakeholders' needs. So for cloud experimentation, we've been recently demonstrating the significant speed increases of running things on the DoD HPC as well as NPS HPC. But I will say that the one lesson learned from this, it's really nice, first of all, to be here at NPS, where we do have access to significant HPC resources, and one of the first places even to have HPC in academia. But one thing is that output data is a huge challenge. So storing, how do you put it in cold storage, hot storage, et cetera? And then how do you process it? And how do you have the right tools available to actually do the analysis required once you conduct a massive design of experiments using combat simulation? And so that's something that we're working through now. For Atlatl and Wargaming, I think you'll hear a little bit more about this, so I won't go into depth when Scotty briefs, but the bottom line is we are very interested in what Scotty's working on, and anything that we can do to help him. We will also incorporate some of this into our future research program, but that's hierarchical machine learning, which will enable potentially the actual using orders type of like what the colonel mentioned, using actual written orders or an intent to control units on the battlefield within a simulation. Whereas now you're really kind of scripting movement in our higher level simulations. One of the key projects for our third LOE that we've focused on for the last 4 or 5 months is optimizing a program called Seeker. And this is a small UAS and counter small UAS capability analysis tool that was developed by TRAC. So this is a validated simulation that was used in studies to inform what counter small UAS capabilities we needed. But what we're doing is applying reinforcement learning in order to make the UAS or the small UAS, both swarms as well as individual UAS, more intelligent, so that we can then see as you build up their capability and tactics, what changes in requirements for counter small UAS capabilities. And so the intent is to optimize with reinforcement learning on the small UAS side, and then compete with sim optimization on the counter small UAS side to get that optimal mix and understand where you get the most, the Army and any other DoD organization would get the most benefit in the counter small UAS fight. I'll skip over this, but in the end, you may wonder when we're talking about training large language models, how we possibly have the resources to do this, knowing that it costs millions of dollars to train something like GPT or Llama or these other large models that are available open source or commercially. And the way that we are doing this is it's kind of a hack, I will say, but you're essentially freezing some of the weights and you're fine-tuning only small portions of these models. So you maintain the lower level weights generally fixed, and then you train in the higher level weights of this network that's multi-layered and hierarchical. And to train those higher level weights, you're just fine-tuning for your particular problem. So you take a model that's pretty good at inference and has a pretty good baseline of understanding of language, but is naive to military language, or it has been exposed to very little military documents. So you can see this flow here where we fine-tune a open source model, for instance, Llama is one of the most popular open source models. We fine tune that with both our code as well as our documents, doctrine, etc. And so the model becomes very good at understanding that sort of semantic information. And then the next step in order to make the model useful is called instruction tuning. So instruction tuning involves essentially making your model good at doing some particular task. So you may be used to interacting with something like ChatGPT, where it's a chatbot. That's the model. That's what the model has been fine-tuned to do, is to chat with somebody and give it answers to questions. But you may want a model that's just really good at summarizing information or answering a particular type of question or producing code. So what we can do is use instruction tuning, it's called, as a second tuning effort that actually makes the model very good at giving appropriate answers. Because if you ever have tried to play with a model that comes straight off the presses, per se, like Llama or something like that, it will give you coherent things, but then it just kind of goes off the rail and starts repeating itself and doing all sorts of kind of bizarre things. But if you instruction tune appropriately, then you can kind of rein that in and make it answer things in a more sensible manner. So by doing it this way, fine tuning, we take GPT 3.5 is estimated to cost about $40 million. Llama itself costs about $20 million to train. The amount of electricity that's required to train these models is something equivalent to like running the country of Bangladesh for a day or something like that. But you can take a model like that and then instruction tune it in the manner that I described above for only about $600, and that's including the cost of actually running the hardware, as well as that includes $200 of actual queries to GPT-4, or a really good model that you're trying to emulate its performance. And so that's kind of it's a little bit cheating because you're copying the way that a current model works, but it's actually quite effective, and it eliminates the need for the reinforcement learning with human feedback that is required, that was originally done and required to make GPT and ChatGPT look good. But that being said, I'll pause there. If anybody has any questions about specific projects, only got about a minute left, so, or 2 minutes left, but is there any more questions? Happy to answer them. Thanks for your time. Thanks for listening to me ramble.
Okay, our next speaker is, you might recognize him if you were here last year. He was not up here presenting as a member of TRAC. He was a graduating student from MOVES. And so he was at demo night showing his thesis, and now he's up here talking about all the great work he's been doing for the last year since he had a long PCS from the second floor to the first floor. So I'll turn it over to Major Kurt Reynolds.
All right, hello and good afternoon, everyone. I see quite a few familiar faces in the audience from last year. Good to see a couple of my classmates in the audience as well. All right, so today I kind of want to talk about move support to Project Convergence, and this is more of a Combat 21 success story. For the most part, this is going to be a high-level brief because a lot of the work that we did was very, I guess I would say, classified. So as far as it's funny, I can talk about Project Convergence without showing you Project Convergence stuff that we did. So that's kind of what we're doing today. All right, so not going to walk you through the wall of text, but the biggest thing that we were trying to solve with our partnership with MOVES is that the Army analytical community that were participating in Project Convergence, we had all these technologies that were kind of playing, and we're doing all these good experiments and going out on ranges and collecting all this data from them. And each individual piece of technology is being tested on a range by itself to collect data from how the soldiers and users are interacting with it. But what we lacked was the ability to kind of see how all those technologies were really interplaying with each other. So if you were to go out and test this drone, how would the soldiers then use that drone in an actual scenario? So what they needed basically was a way to actually get a chance to look at how all those technologies interact with each other and then interacted with the actual end user in a given scenario. So the big focus here was on the sensor to shooter kill chain and more of a focus on long range precision fires in an experimental environment. So that's kind of the big crux of the problem that we needed to solve and why we got MOVES involved in the process. And all this being used to drive informing senior leaders on the current state of those technologies, as well as their potential impacts on the warfighter as we get ready to transition to basically that multi-domain operations doctrine for how we fight. All right, so for a lot of you are already familiar from a high level what Project Convergence is. As Colonel Jablonski already hinted to, it's basically changed from just the name Project Convergence to now a campaign of learning with a focus specifically now on, this is 2022, and we're going to do each of these particular iterations is now going to be called a capstone, essentially. So it's still going to be Project Convergence or PC, but it's the C is now going to be capstone 4, capstone 5, so on and so forth is kind of what we're leaning towards. So I've got 2 very short videos. The first one's kind of just like the AFC PR buzz for Project Convergence for what it is. The second one, what I really want you to focus on, since I can't dive too far into the weeds as far as what we did in the CIPR lab, is basically take a look at each of the technologies that they're flashing there, because those are what I'm going to basically be highlighting as we kind of talk through more of the processes of how we actually got after modeling some of these capabilities.
I think it's the Facebook one.
Facebook one.
Yes.
So first video.
It's an experiment that tests future capabilities to defeat our potential adversaries. A campaign of learning. A mission to gain the ability to converge effects across all warfighting domains. Army, Navy, Marines, Air Force, Space Force, and our allies working together to solve military challenges and strengthen our defense. Project Convergence 22, because tomorrow is worth protecting.
All right, so that one's basically just the PR piece. This is the one that I actually want to highlight and pay a little bit more focus on, and just take a look at each of the key technologies that were used throughout this particular video. Okay. All right, so you probably noticed quite a few. All right, so you kind of notice a big flash of a lot of things: aircrafts, drones, artillery pieces, naval vessels, a lot of integrating moving pieces of technology that all went into feeding what was actually being looked at and collected on during Project Convergence actual on ground. The operation took place between Camp Pendleton as well as the NTC, National Training Center, both here in California. So after all that data essentially gets collected, the next step now is to take that data and actually work it into a simulation that combines and integrates all those capabilities into one seamless form that can then be used to inform actual analysis. So what we started with was a baseline fire scenario that was provided to us by the White Sands Missile Range team. So they basically gave us a baseline capability built within Combat 21 that we're able to then build off of. So the next piece was what I basically did on ground. Part of it was going to each of these sites, taking a look at what technologies were used, collecting as much information and knowledge, and then also making sure that information gets properly shared with the team back here in moves, so they know actually what pieces of technology are being used in this particular scenario. So the big piece to that was then leveraging Combat 21 to explore those features in an actual operational scenario. The scenario itself was pretty big. So what we ended up having to do was scoping it down, essentially. So instead of taking a look at the entire scenario A or scenario B, we basically looked at a small vignette out of one of those scenarios and said, okay, let's take a snapshot of this particular segment of the battlefield, take a look at how many pieces of technology are actually interacting in this space or potentially could interact in this space, and let's model that within Combat 21. So some of the data that we had to collect, since we couldn't necessarily just run it all or try to get all that data all at once real time, it came from ProModel, another modeling tool used more for process modeling, essentially, for the most part. But ProModel had timing data that was relevant to how long it takes for a satellite to acquire a target, for example, or how long does it take for a command post to actually process the information they receive from a sensor and then make decisions on whether to deliver fires on that particular target. So a lot of that timing data was actually collected from ProModel that then went to inform our work that we worked on for the actual development of the Combat 21 simulation. And then the third key goal that we had there was to represent new technology with the capabilities that were already inside of Combat 21. So as we know, a lot of these models that have already been built and established, they don't necessarily automatically have that new gun, that new missile, that new rocket that you have. So a lot of times you end up having to surrogate already existing capability, but then the ability to modify those parameters, you know, the speed, the sensor, the range, those key attributes that make that new piece of technology sing are what we really need to replicate in the Combat 20 in order to make it model or replicate that actual scenario in a more realistic way. So the key thing for us was basically the deadline to have a deliverable, both a product and potentially the data that was available to the analyst within TRAC to then further do their reports and then provide that information back up to senior leaders. All right, so let's talk about what we actually modeled at this point. So I'm kind of walking through the step diagram. In your minds, I want you to imagine that video that you saw 2 slides ago, right? And the technologies that were physically being shown there, and then just put those in place of the graphics that you see on this particular diagram here. So the simulation starts, and we start in the space domain. As a satellite continues to orbit the Earth and goes over the battle space that we're particularly concerned about, the satellite picks up or detects an enemy signal. From there, that information is automatically relayed to a command post. The command post then processes that information in a rapid manner and deploys a UAV. So while the satellite was able to detect, the UAV goes out and rapidly identifies that target as a confirmed enemy unit. From there, the CP is able to rapidly gain that information in real time from that UAV asset. They clear the fires and send the directions down to a firing unit. From there, those units armed with new types of munitions that have increased range, speed, and levels of lethality are able to then deliver fires upon the actual enemy target. From there, the UAV automatically collects on that data and provides real-time updates to that CP to give them their battle damage assessment. So that's basically the scenario in a nutshell. A lot of it sounds fairly familiar as far as things and tactics that we currently use in today's day and age, but the modification and the integration of being able to provide that satellite imagery and the interconnected nature of each of these technologies is a key feature that we're focusing on for how we're able to actually build this in the actual Combat 21. When I say build, this was not TRAC actually building this. This was the Moves team building this. So we partnered with Dr. Below and Mr. Michael Kraus, were the primary builders for the tool. And I was acting as the primary liaison to help facilitate communication between our TRAC team and the customer at White Sands Missile Range. Okay, so continuing on with the approach, as I said, a lot of the information was a combination between Combat 21 and actual ProModel data. So this slide just highlights exactly what came from us designing it in Combat 21 and where certain information from ProModel data helped to facilitate those timings. I'm going to take one quick step back to the previous slide just to show that for certain capabilities like the satellite, for example, doesn't already exist in Combat 21. For things like that, we had to basically use high altitude aircraft and then change its parameters in order to modify, to replicate that satellite capability. Then feeding in the pro model timings, you're able to now pick up the sensor timing for how quickly that satellite is able to actually detect and then push that information on for its detection onto to the command post. So the results. All right, so in order to collect results on this, what we ended up doing was comparative analysis. We were given a baseline scenario from the team at Wismer. And so that scenario already had in it basically the current process for how we already decide, detect, deliver munitions, and then assess the damage that we produce on the threat. So we basically ran a number of iterations on that baseline scenario and collected data on how long does this process take if we were to do it the way that we do it now. Then, after going through the process of adding in the proper timings and the PC-22 technologies, ran it again, multiple iterations, and collected the data on what does it look like with those technologies integrated into the force and what they're fighting with at that point in time. And what we noticed at this point was a significant reduction. Like I said, can't give specific numbers, but we're talking about the difference between hours to process on certain targets to mere minutes, as far as being able to actually execute fires and gain assessments on those same targets. So fairly significant as far as what the capability could potentially deliver to the force, assuming all those technologies work correctly and have no major issues and are actually brought to the force in their intended form. So those are all caveats that we have to take into consideration for this. So let's talk about some of the future work, since we know that PC is not going away. Right, so we basically deemed that the work that we did with the moves team here and the work that we did in Combat 21 was a success. They did deliver value. So what's the next step? So things that we can look at as far as expanding on this relationship, expanding on the work that was already done, is potentially expanding that vignette into a larger scenario. Right, we only took a small snapshot of a full-on scenario, but what if we're actually able to look at more space, more enemy capability, or more of our technologies that were actually integrated into this process? Another thing we could look at is additional scenarios. There were several scenarios that were actually observed during PC-22. So all the way from looking at a defensive situation to an offensive scenario as far as how we actually employ those particular technologies. For us, we took one specific scenario and one small vignette out of that. The next step may be looking at exploring some of those other scenarios to see not just how it performs in a defensive posture or an offensive posture, but maybe what it looks like in both offensive and defensive, and what about the transition space in between. And then the last part that we talked about possibly looking into is gathering the simulation data and running the sim prior to actually going out to the next PC exercise. So not only are you going out there just in the desert, seeing what the things can do, but you actually have something to measure those results against. So that could be something that we could look into as far as taking the model that's already built at this point in time and using it as a tool to measure actual performance. So that, for the most part, concludes our use for Combat 21 and how it was successfully employed in support of PC-22 with the moves team. What are your questions?
Can you talk a little bit more about the model and how it fits in? Was it part of, does it run in conjunction with Combat 21, or does it provide a recommendation what you would program in Combat 21 to achieve?
Okay, I could talk a bit more about Pro Model. So Pro Model, for the most part, we didn't use it in real time with Combat 21. What we ended up using from Pro Model was the data collected, or the data that it produced. So the timing data from Pro Model provided us a range for how long about average that it should take to pick up or sense, or how long on average should it take to decide to send out a UAV or to actually deliver the instructions on delivering fires on the target. So we took that average of data, provided a range for the sensors in Combat 21 that it then operated off of. So it's more just, Pro Model is more used for the data collection piece that helps to inform Combat 21.
Are you talking about collecting the data from live training scenarios or actual combat scenarios to get that?
So a lot of the Pro Model data was collected during PC-22 actual. So yeah, so it did come from the experimental on-site data. So imagine they're doing some action on a range and they're simultaneously collecting that data on that range that then informs the Pro Model. That Pro Model data then led to what fed into the Combat 21 model.
Did you guys have any overlap with the Marine Corps Warfighting Lab at Will during any of this execution?
Not directly. I know as far as any technologies that were used out there, if it was used and collected on, there was some chance that that data may have ended up in the pro model in some way, shape, or form, possibly.
Quick slide number 2. Just want to compliment you guys on the design of the permits here, because this is a joint problem.
Yes.
Big time. It's not just Army Navy, but Marine Corps too, and maybe other folks, and that's great. Dude, how rare is that? You know, where's the Navy version of that? Where's the Marine Corps version? Where's the joint version of that? That isn't part of the normal mix right now. I just want to point out that gap to you, that here you are straddling it, yet it's a shared problem, yet we're still not talking together. So it's very encouraging to see things like this and how we might work better together in a joint plan.
Right.
Kurt, one request and one question. The request is, can we get the video that you showed?
Yes, it's on YouTube, on class, so yeah, definitely easy to share.
Okay. I want to use it for a brief next week about operational energy. The second question is anyone, so during this whole project convergence piece, was there anyone looking at or thinking about the new forms of energy that they are considering being used on the battlefield and what the impacts of those energies forms are going to take on that picture?
So I can't specifically answer to that question. That may be something that may be potentially explored during a the next project convergence iteration, possibly.
Right.
But
so to the best of your knowledge, there wasn't anybody looking at it this time.
Not to the best of my knowledge.
Okay, thanks.
How did you guys simulate the red ships?
As far as the red ships and vessels that were there, those were done doing standard Combat 21 scripted behaviors or behavior trees, as we're already familiar with at that point.
And those are not direct. They're not. There's no sensors or emitters or anything else.
No, not for those particular ones.
They were just classic targets sitting there to be shot.
Okay, and then I guess
Exactly how we refer to these.
So they had no offense or defensive capabilities.
Yeah, no, I mean, actually, we talked about it. There just wasn't time to get into that.
Are you guys validating your results? Do you have a plan to go back and validate them on further exercises? Because there are efforts that are similar to this, like in Northern Edge right now is coming up. So I don't know if you guys are piloting any of those.
Northern Edge, not specifically, no, not at this time. So the last iteration that our interaction I had with Project Convergence, or the work that we did with Combat 21, was with Dr. Below's team. So the big thing for us was getting that deliverable packaged up and ready to go. Last minute changes like working through some fire iteration with smart munitions, or trying to work through some of those challenges. But as far as applying it to a different problem set or going back in and adding in some of those other capabilities, we've not done it with the model so far. So
I think this specific scenario, there's quite a few efforts going on across the Marine Corps and the Navy where you could use this sort of as a template for the work that you did, and you're just changing some of the variables because specifically the Nile that's coming up with Will. We were just talking about they're trying to incorporate some training into the experimentation, and we were talking about figuring out what sort of metrics we want to collect on to sort of look at how would the simulated event carry over to execution in real life. Right. And so they're trying to figure that out. And one of the things is how we collect the data, and then how do we sort of build enough of a data set to find out, are we making a difference in the training aspect of it?
Oh. So I guess just speaking to that, and then like tangentially, I guess speaking to it, I guess one of the ways that we looked at it was probably what we mentioned in our future work. So you use a previous iteration, you collect on the data, you build the sim, you run it to get your proper timings for how long you estimate that it should take a proficient or trained unit to do it. And then you use that to kind of inform or gauge the training once you go back up after the fact. So that's probably one tactic that we can use to do it.
Can you talk, Mike, on how this project ended up here and how Combat 21 was included the project Convergence lead on the TRAC-MTRY. Said, I need you to collect this data from everybody on it.
So Dr. Blow can speak a little bit more on that specifically, but from my purview, or at least my understanding, I think the relationship that we happen to have here with TRAC-MTRY being co-located with the Naval Postgraduate School, TRAC-WSMR uses Combat 21 heavily in their analysis and their models, essentially. So knowing that we have some expertise resident here at NPS, TRAC-MTRY is here and can help to inform that team, that relationship kind of naturally kind of led itself to what we ended up was like, hey, these guys are here. Why don't we use them to help us inform on this particular situation that we have here?
Yeah, just under the hood, there's a lot of SimKit involved in this, right? Was that part of the methodology or we're using other functionality?
No, SimKit's not part of this at all. So SimKit is really, we just use it.
Sure. And my understanding is, Kurt and I were talking about this last night, Comet 21 has BIS output. So
really limited.
Yeah, so maybe really limited.
But just output on.
Very good.
Yeah.
So the thought occurred, one of the things since we do have a moment right now is to talk about a future, and I don't want to get on anybody's clock here. Gee, if you can't output your results, and gee, the problems are shared, and gee, we have other simulations, gee, then maybe having those streams saved would be really good, because then we could use them for library constructed mashups. We could substitute portions of, well, you didn't have this other thing, but let's add that. And I think we changed the logic of this robot over here. What happens now? It's not magic, but it might aggregate. And so I don't know. It just resonates with what we were talking about from a completely different angle.
Right.
How could things work together more? And
Don, I think on that, from the training perspective, we've had some discussions, especially as we start to move towards things where we're employing experimental systems. We need to show sort of the training audience, you know, what right looks like. As we start to have rotational units coming through, we want to show them this is capability that you may see, but you're never going to have it in training because it's such a low density asset. We're able to then, you know, through something like this, show different ways that you would do this process. If you had X system available or Y system available, even if it's just vignettes and you're sitting as a God's eye view in a virtual market, I think there's value.
And one other thing about, you know, the idea of the DIS output is, you know, I think there are places where taking DIS and using ChatGPT or other forms of AI to basically turn it into something human readable. So instead of just a whole bunch of thousands and thousands of PDUs, it can tell you exactly what happened in the battle by reading all those PDUs in a method that, you know, I think Colonel Jablonski talked about it, is that, you know, the general wants the, you know, the debrief the day after it happened, and the analysts don't have time to do that. And that might be a good way to at least create, you know, an 80% solution to that, and then let humans go in and massage as necessary.
I actually saw that specifically happening at PC22.
Okay,
They were collecting
excellent.
on the PDU data. There was a guy literally sitting at a desk parsing all that data himself, and that is definitely a use case where the tool could possibly come in handy to help answer those questions. What came out of the simulation versus having somebody have to find that data, then do all the visualizations for it manually.
Barry, do you know if there's any student research that's doing that right now?
I don't believe so. Scotty knew a little bit about it. Are you here, Scotty?
Yeah. So I have a Oracle Crater, believe it or not, with a small startup AI company that's very big, what we talk about. Right now we're trying to do a proof of concept with them from beginning to end Wargaming. So human define the scenario, use large language models to create that scenario, for example, in Atladdle, play that scenario through AI. On the backside, save all the state information, save everything, be able to and use large language models again to do a quick analysis and debrief of what happened. So we got the playback, but we also have a text description. So this is kind of, we're in outline phase right now, so we don't have anything. I think it's definitely possible to show proof of concept beginning to end. So that is something that is not going to be core to my research, but I'm very interested in demonstrating the value on the NWS.
nothing else, I yield my time back. Thank you very much for your time, everyone.
Thank you very much, sir. Our next speaker is Captain Bill Sherrod, who's going to be talking about the NWSI here on campus. And a lot of great work they're doing there, and a lot of great work that is going on with moves. So, Captain, take it away.
Hey, thanks. So I'm formerly affiliated with NWSI. Now I'm the director of strategic initiatives at NPS and the Air Warfare Chair. And because of the Warfare Chair, you still have this love relationship with NWSI. So I'll talk a little bit about what NPS is doing.
Your Zoom setup's not going correct. It's up to. All right, in a second to do that. You want the next slide?
Yep. Okay. So when Rondeau spoke to the group this morning, she talked about the 4 elements of our strategic framework or where we're going. And so really an important point is for this group, and a question was raised by one of the members with respect to Navy view, education, talent development, importance of M&S. And really it's a question for this group to try to consider how to answer because there is a delta between the work that is done by the leaders and experts and folks cutting a path in the M&S space and GIMS writ large for DoD and with industry partners, and the value criteria that senior leaders at the policy decision-making circles have in terms of what we invest in and where we set our priorities, right? Moves has been around for a while here at NPS. It's been certainly within the DoD sphere for many different things. And it, like AI, like ML, is one of those for, an analog gauge operator. It's a magic black box. It's just supposed to give me more better stuff, right? It's hard for folks to understand what the applications are and how that translates to the things that they use to make decisions. Whether it be, as the president talked about, on the Title 10 side, the man, train, equip, right? Prepare the force generation side, or the force development side. And there's, risk associated with the current naval approach, which is almost exclusive focus on LVC, which results in intense amount of energy and activity in one area without understanding the connectivity and importance of all the other things with respect to M&S and its capabilities, right? And then how do you develop the talent appropriately? Because there is a level of knowledge that's required for all. And then as you start to have the taxonomy working up towards senior leader levels, what is the level of knowledge and understanding of M&S, of experimentation, of gaming, of machine-enabled decision analytics, and what that looks like, so they know that they're making the right decisions. I think a comment was made earlier with respect to trust, right? How do we get the pachyderms to trust what M&S provides in a way that they understand and can make informed decisions that clearly link to outcomes? And much of the challenge we have is the depth and technical expertise and fidelity with the work and the various projects and activities that are happening. Exquisite in terms of detail and importance, but the connection to that warfighting outcome that a 3-star is going to get when they got to make a budget decision and a crunch that's PowerPoint deep, and being able to bridge that gap. And that's one of the challenges that we have, right? Both as an institution, right? Because where we find ourselves is that the work and the research is done as defense focused and naval relevant, based on over 98% of the sponsors are DoD or government sponsors for our research. Over 60-something% was DON. So naval sponsors of the research, to include much within the MOVES portfolio. And yet that is aligned to a 30-year S&T plan, and our 3- and 4-star decision makers, no fault of their own, are focused on POM build and the 3-fit buy, right? When we look at the NAV plan, we're focused on NAV plan 2022 implementation and the force design for 2045. Those are mostly platforms which exist today. What we don't have is a lot of the models to go along with those platforms for us to understand how to properly man them, to operate them, to sustain them, how to employ them. and how to look at alternative futures of total force deployment when you have a force-on-force engagement, right? That's the space, right? And there's a distinction between, all right, the tools and the research to build the tools and capability. And we have to do a better job as an institution, right? And as an ecosystem of communicating that up. So those decision leaders, those graybeards, have the ability to make an informed decision and prioritize the investments, not only in the people, but in the work and the actual projects themselves, right? That they understand the connection and how it started with this group here and the passion and work that this group does and others of like-minded and like capabilities. And so extending the reach and impact of naval relevant education, the increasing the impact of the applied research that we do. So it's not just to dismiss or move away from the foundational academic research that is classic to the American university system, right? But it's to do that and to do the applied, because one of the measures for the ROI on the institution and then by result is all the research and all the things that happen within the institution is what are the outcomes? And the outcomes are not measured by degree completion, right? The ability to see that ROI, particularly if there's low utilization by the service or not a high billet throughput, right? If you only send 4 a year, that makes it real hard to show the ROI on the education. The proxy, for lack of a better characterization of the ROI, is not just the educated, upskilled knowledge and skills of the warrior scholars who leave here, of the total force, officer, enlisted, and defense civilians, but also the ability to show solutions that transitioned and added impact. So it's not just the education, it's not just the research, but it's with a keen eye towards working on problems, working on relevant problems when folks roll in from the fleet and the force with a problem set and a passion to start to go through what is referred to as that innovation cycle, to curate, to ideate, to prototype experiment, but eventually transition things, whether directly hand over to those that come in behind them to continue the academic journey to help mature and drive transition, which ultimately leads to adoption, right? If the end state for innovation is about adoption by a community of practice or adding value to an organization or entity, how do you add that value? By providing something that is useful and utility that is also different than what they currently do. Much of that is within the MNS space, and what we're talking about, whether it be from acquisition and talent management, adding the generative capabilities that are emerging into both the development, but also the analysis of, and then how we employ that. And that's the space where, when we look at what MOVES has done and this ecosystem has done in the past, how do we build on that with an eye towards where we need to go in the future and how we close the gap, the understanding gap? One of the most important gaps for the viability of the ecosystem is closing the understanding of the imperative of what the knowledge and skills and tools that are brought to bear through this capability in order to focus on what the vice chief and the secretary are focused on, and that is clear outcomes that lead to warfighting advantage between now and 2027. And if we're not focused on showing how we are contributing towards that very tangible data on a calendar in a measurable way, then it's going to be viewed as activity and it's interesting, and I don't see the connection. And as old vice chief once said, who was pretty hard on the metrics and tight on the coin, if I don't see the relevancy, then I also am not going to invest in. Right? So if the relevancy is low, the value is low, and so too will be the investment sustainment, right? So there is an imperative beyond just our duty with how we are aligned and focused, an imperative to make sure that we're showing clear outcomes and driving towards that purposeful capability build for the force in ways that only this group can provide, right? So part of the NPS transformation was taking and really consolidating much of the education programs that we had, because if you looked at the calendar, it was pretty dated. It was a lot of things were on the map, and at one point there was over 200 different educational products available between in-resident, distance, PhD, short courses, all that type of stuff. And a hallmark of NPS is a lot of interdisciplinary work. Another hallmark of NPS is the ability to be very responsive to individual sponsor needs. However, without a validated requirement, those became desirements, and we built a lot of programs and built a lot of labeling that resulted in, from an outside view and from a resource sponsor's view within the Navy, a lack of coherence. And so what we did was we cleaned house a little bit. We organized around clearly things that are defense unique, naval relevant, binning and organization of degrees still awarded by the departments in a way that is coherent and stands out. So folks can't say, well, why don't you just sell that place and have it all be civils? There's a reason, because you're not going to get combat systems at civils. You're not going to get a defense-focused management education. And you'll note the modeling, visualization, and simulation is a standalone program, right? Highlighting how unique and important it is, but also calling out a unique opportunity as the president alluded to, moves 2.0 or moves of the future. Where does this program go with a research portfolio that again has a keen eye on developing the workforce with the knowledge and skills, while also developing solutions that can be scaled into the fleet and the force and the supporting establishment in a way that adds value and makes a difference between now and 2027. But the education program is the backbone upon which that work is done. So when we look at the 9 program areas, in the middle, what we have is the 5-step innovation cycle process. The NPS comparative advantage, as many of you know who have been here, have studied here, who work here, is the Warrior Scholars. Okay, across the NRD&E, and I'm just going to focus on the naval aspects. Across the NRD&E, they had the ability to connect with industry, and they had the ability to partner with academia. They had the ability to get perspectives from the fleet and the force, but it's on demand and it's at small scale. What NPS has is the ability to have the perspectives at a quarterly refresh of the joint force every quarter, a couple of hundredfold, where you're bringing in mid-career officers, senior NCOs, DoD civilians, engineers from the labs and warfare centers with context from their work domain and insight into problems, and the ability to start to work on solutions to solve those problems. And in many cases, because they will be the end user of either not this technology, but a similar technology downstream, can help understand, help us define and better develop the adaptation necessary to move those capabilities into transition. And where that really matters is you have the end user in the development cycle up front, an important aspect of innovation and the entrepreneurial community. But we're able to do this now through students coming in, design, human-centered design thinking and other exercises, leveraging hacking for defense and other innovation approaches to come up with minimum viable ideas. And then through their journey, taking both the disciplinary, remember the Title 10 is about the theory and practical application of their warfighting duties, right? So the theoretical and practical application, developing minimum viable ideas, field prototyping, rough experimentation, and the ability to try to refine a solution set that map towards things that look eerily familiar to the NIF 4+4. Purposely so. Again, showing the relationship of the education that is unique at the Naval Postgraduate School, whether in resident, DL, short course, whatever, and the research that contributes into those areas. And there is, in addition to having its own dedicated call out for alignment, M&S is an enabling capability that cuts across all of them. The ability to do the analysis, the ability to understand, to design the systems, right? To be able to do end-to-end for what its sustainment means, the implications for the force. The whole point is that we're trying to demonstrate that we are not the lead, a lead in innovation for the DON and the DoD, because we recognize that many of the solutions have to be applied in an all-domain joint force environment, right? It's a joint fight, it's an away fight, it's an all-domain fight. How do we prepare for that? How do we align how we're developing the talent and leveraging the work that they do in that education journey to contribute towards outcomes? That's the focus of where NPS is going. And that's an opportunity space as moves looks to see how do we position ourselves to add and accelerate in that area. Okay. The relationship with NWSI is pretty clean and simple. NWSI is a connector to the fleet and the force. In addition to the expertise and experience of the students that are coming in, the warrior scholars, what had atrophied over time was a clear connection to the fleet and the operational headquarters with what the priorities and the challenges were that they were seeing on a day-to-day basis. And how to help make sure that the education that we're providing, whether again, in residence or short courses, and the solutions were grounded in things that are going to be relevant, right? There is no insight quite like operational insight to help inform a researcher in the journey that they're going on, right? And in many cases, there's work that's happening that we may not be aware of, and it's a way to draw in inputs to help shape and focus the work that we're doing. Particularly when we're talking about things that are behind the iron doors in a highly classified department environment, right? If a basic researcher has been working in an area that is predominantly unclass and not thinking about the highly classified applications of the technology upon which they're working, the ability to engage with the fleet and the force and gain those insights now help them accelerate the solutions and refine their work that they're doing to contribute to the body within the discipline. And that's important. It's both important for the academic credibility of the institution and adding value to the discipline, but also for making sure that we are razor sharp and keenly aligned to where the fleet and the force are and seeing the same challenges that they're seeing. But adding from this deep bench of expertise, the places an opportunity to improve. NWSI is a partner with the Office of Research and Innovation. So previously, the Dean of Research Office, then the Vice Provost of Research, was really sort of a transactional deeds and grants. That all the external agreements, CRADAs, EPAs, those types of things, MOUs, MOAs, kind of just held that. But there's recognition that the power of academic research and intellectual discovery has been built on individual relationships of faculty members, researchers, PIs, principal investigators, connecting and developing a portfolio. But that portfolio is based on the strength of that individual and their network. How do we leverage the network of the institution? How do we garner the resources of the institution? How do we gain the advocacy of the institution? And some of that has been through, in addition to valuing and preserving and still supporting faculty with the development of individual CRADAs in support of research. In many cases, some of the CRADAs involve students doing projects and the faculty is the PI, the students doing the work with industry partner, but seeking out institutional strategic partnerships with multi-project opportunities in there, sometimes overlapping, sometimes very disparate in their nature, to focus on things that are keenly interested in recognition, both internal and external, to start to drive towards leveraging other people's resources through the CRADA, right? Some of our industry partners who have the ability to bring resources that we could not bring to bear to help us co-develop solutions in a way that brings speed to the fleet, all right? That is the intent behind the strategic partnerships. The first one that was out the gate was with Microsoft, and many folks have heard about the Microsoft partnership, right? 4-project CRADA with a couple of different things. It's down selected to three projects and continues to be in its second year. A lot of organizational learning for both stakeholders as we have developed conversations and worked on capabilities. You know, warrior scholars having the ability to be fully immersed in their industry development cycle, right? Scotty's my favorite top vignette because he had the ability to have a tour with Industry Light while on his doctoral journey by getting thrown into the lion's den with Microsoft as they're doing their scrum and seeing and understanding and being a part of that dialogue daily with them as they're developing solutions towards a capability. But more importantly is whether or not that capability that he was working on as an advisor to that project team, whether or not that transition, what it did drive was a conversation that before was not possible to have. And that's about how do we bring modeling and simulation and digital analytics into the wargaming space. And now that dialogue is happening. And that would not have happened had we not broken some glass, but really learned alongside with our industry partners on how to do things differently. And that's the opportunity that we seek through the strategic partnerships, okay? And so we continue to pursue those while also working the individual CRADAs. And then all of that still ties back to right now the academic mission, the development of the warrior scholars, providing the graduate level research opportunity commensurate with their graduate educational experience. But in many cases, trying to provide a little bit more practical hands-on, working with industry, working with the latest technology, as opposed to working with some antiquated, dated theoretical things. That as we're bringing capabilities in, we're modernizing our own research capabilities, that we're able to give the opportunity for the fleet and the force, the total force, an understanding of this is what it actually means. So whether or not they take that solution set with them into their follow-on utilization tour, which some get to do, they have an understanding of what it took to get there. And so when they're downstream in a tour where they are faced with new technologies, they know that they have the knowledge and skills because they have lived experience by learning how to adapt it and adopt it and make it relevant for them. And that is living and learning, right? And then that's one of the ways that we are able to scale innovation throughout the force. When we talk about the innovation concept, this is a strategic thrust for President Rondeau. She talks about the guidance, the strategic documentation. It is clear. Whether it's in the national security strategy, the national defense strategy, even within both Tri-Service Maritime, the NAV plan, and the Commandant's Force Design, what you have is a call for innovation. And innovation for some is Rondeau likes to say it's a Rorschach, and it absolutely is. But it is also a repeatable process, which means if it's a process, you can apply the system to execute the process. So while NPS has historically educated about innovation and has done it in pockets, much like DoD has pockets of excellence within M&S and it's got areas where maybe it could do a little bit better, so too with innovation. And what we're focused on is developing an integrated whole of institution approach to the innovation pipeline that leverages the disciplines and all the comparative advantage, the warrior scholars and the faculty advising and developing them through an academic journey. To go end to end from a WIC, which is concept development generation, design-centered thinking, getting a wicked complex problem in a future context, and developing minimum viable solutions through teams. Handing those over into a next team to be able to develop, work with industry and smaller teams to sprint and crash, develop prototypes, and then be able to use the field experimentation capabilities either at GIFIX every quarter or outside of the GIFIX window, because there's still NPS field experimentation capabilities, both at Camp Roberts in the Bay or wherever the fleet and the force are, to be able to experiment with those prototypes and then be able to hand that over to the defense management team and work to develop a deliberate acquisition strategy for that capability with a Title X customer as part of that, which has been probably the missing component for much of the innovation activities within the institution. When I say at the beginning, we're keenly focused on and should be focused on that transition of capability, that's the important point. All the good work doesn't matter if it sits on a shelf or sits on somebody's hard drive. It's got to have an impact by being utilized somewhere, right? So we have to be able to drive that transition. And that is a key aspect that is a differentiator from what we've done in the past, but now what we're trying to do as a whole of institution. So still inside of that is the academic journey, right? Touch points, there are courses inside the WIC. That's a whole curricula, right? So this overlay can be a multi-year journey. It can also be a sprint, right? We have the ability to scale and do in shorter. It's all tied to the resource and it's tied to the problem, okay? But unique to this is the 2-year journey that is the MOVES educational program is the ability to look at how you inculcate and overlay this as part of that development. As you develop graduates of the MOVES program, how do you curate? How do you ideate? How do you prototype? How do you experiment? And how do you help drive transition as part of that journey where that one degree, that one education, that one research portfolio does the entire shoot and match end to end. That's the one program that has a unique ability to do that compared to the others. And it's a tremendous opportunity space when you think about where the institution is, where this ecosystem is, the opportunities that you've discussed today, and the challenges that you know are within it, how to bring coherence and focus and prioritization to what you do moving forward. Because when we do that, we close that understanding gap, then that's where we're able to engage with the old 3 stars, some of which are joining us today, but the 3 stars to be able to be the advocates to go, I want that and I'll invest in that. Because we're able to show how we transition and what the outcomes can be. That's where NPS is going with respect to education, research, and innovation. And the vision is downstream that there is a Naval Innovation Center, which is a facility purpose-built to bring in industry, academia partners to work both unclass as well as compartmented levels of information to develop capabilities at speed and help facilitate that transition. And I think I'm at time.
You have 8 more minutes, sir.
Any questions?
Sir, how do you get the fleet involved in this process?
So they're great. There's a couple different ways. Fleets get first and foremost the warrior scholars. I do not discount them from fleet experience. The distinction is we also have to make sure that what the warrior scholar problem is, if they walk in, the lieutenant, the 04 that comes in, we're able to build that bridge with typically the ACOSs on the staffs that have similar problem sets, right? NWSI does that. The Work Innovation Continuum, right? Under NWSI, they do that. You invite fleet representation to these events. Sometimes it's inside the war games that would happen as part of the WIC continuum. When we do the Naval Innovation Exchange Team, there will be a summit that's going on for the intelligent or integrated, whatever the I is. The IAS systems, the Autonomous Systems NICS, is kicking off with a design workshop. That's going to have representation. It's going to be all DoD first, right? And then we'll start, get fleet experience and input into that problem set as they start to build the design for minimum viable ideas, then look to see if we curate with industry partners, those who want to collaborate and build those teams to now start to run, right? And then through that process, we're able to learn, co-develop, down select, and move things along. So those are the many different touch points where we see the ability to have fleet engagement throughout, right? Great question. What else?
Does MOVES have its own individual group, or like you said, it's kind of spread across the board, and how is MOVES integrating this innovation concept?
Well, that's a great question. So MOVES is, in its current instantiation, is an interdisciplinary, right, institute that has, of course, a curricula that is managed by a department or granted by a department, right? Degree awarding authorities of the department. There are discussions about what that looks like moving forward for the institution. And I think, you know, this stakeholder group is an important one to talk about how to best optimize the talent, the portfolio in a way that delivers relevancy, that looks at what the needs are for developing the talent, right? It's going to be a challenge to continue to try and get a lot of in-residents to get the knowledge and skills where they need to be across the force, particularly when you talk about there's got to be some level of knowledge for all, and then you start to work that pyramid down, right? When you talk about what is the appropriate a master's degree level, probably fits somewhere near that top level. Whereas we need to be able to look at what the short course offerings are and how M&S integrates into enabling the other educational programs across the force, right? If it's a key component that goes into acquisition or goes into ops research analysis, goes into many of these other things, then there's got to be at least a foundational understanding of what it actually is. So we move away from the old analog steam gauge bubbas and saying that it's more of that magic in a black box, that we develop that. But we have to help frame what that workforce development knowledge and skills looks like. We're doing the same thing with the AI Summit in terms of what AI knowledge and skills are. And I see that there's a direct overlap be able to lift and leverage that taxonomy and approach to the same thing for the M&S across the total force. And then look at what is the appropriate portfolio. Again, the naval focus is heavily on the LVC. What are the other things? What's the vulnerability by over-rotating in that? Right? We need to make sure that we have the site picture on the application. And we know that our IW community is keenly interested in growing, expanding, and its understanding and working with M&S as it helps them move away from the magic mythical, I'm going to roll a dice and give you a red card that something happened. How do we actually model, no kidding, what the effects would be when we start to think about how we apply fires, right? What's the role and space for that? That's a wicked, interesting problem for our IW community. They want to know more. They want to know more yesterday, right? So how do we build both the talent to do that and the pathway to show that we're moving forward with speed? Does that get after the question?
Yeah, that sounds right. Just probably looking at what is actually being worked on in detail to help kind of illustrate where those connections, where those dots are.
Yeah, I think so. Remember, MOVES is the one program that has the ability to do all of this inside its 2-year chunk journey, right? It's not how it's built today. Has the opportunity to do that if that's what makes sense with the sponsors, the fleet, and the force. And there's a way to appropriately line the curricular so we don't, remember, the intent is to do no harm to the educational outcomes. We need to make sure that we develop the right knowledge and skills at the right time. But there's the ability to look at how we leverage that and connect it inside of these things. Okay. What else?
So innovation and research and development normally require failure. That's part of the process, right?
Mm-hmm.
How tolerant do you think fail or fail faster is within the DoD space overall?
I think your mileage may vary, right? I mean, let's be honest. It depends on, and it certainly depends on where the failure occurs. I think there's also a way to how we frame it. What did we learn, right? So if we're demonstrating the ability to learn. So our experiment, our advance with one of our industry partners may not have generated the outcome that we expected when we started, but we learned a lot from that and we changed the dialogue. Now, what do we do stepping forward? Okay. If we stop there and count as a failure and then walk away from it, then it absolutely is. If we integrate that into what our takeaways and insights are and develop the next iteration that shows what we have learned and how we don't repeat that, then that's value add, and that's part of that pathway. I think the distinction is, quite frankly, the speed at which that type of learning happens as part of the foundational research that feeds into the 30-year S&T plan versus capabilities that need to be part of the POM build today, right? That's the delta, right? That's an exaggeration, but that's really kind of the space that we're trying to bridge, because the stakeholders don't understand, in some cases, don't have a full mature appreciation for that our site picture and the research space is looking for during the next generation capabilities when they're worried about fielding current capabilities and things that are on a program, right? And so we have to show the ability to have an effective balance to do both. We're certainly not walking away from that basic foundational research by any stretch. But what's very, very important is for us to be able to show where that foundational research, where we envision this contributing to in a next generation capability, back in that NIF 4+4, right? It's not just about developing for today's fleet and force and the next one, but the one beyond, because that's where that would manifest. So how do we have an eye towards that while also assuring folks that we're doing things that are relevant inside the things that are most highest consequence, most pressing priorities for our naval leadership, and that's the NIF 4+4 between now and 2027.
So it seems like it's easier to control some of the stuff in-house here locally with those first portion of the columns, but the transition piece, like what are you able to do to help? And that's the thing that it seems like it's difficult with a lot of stuff that when there's, whether it's flight force experimentation or research or whatever's going on, how does that actually affect the JSITS process or the warfighter or the training capability showing up sooner?
So that's a great question. So in innovation capstone, so that is leveraging the 1 year in resident program, and they develop an acquisition plan. They develop the acquisition strategy. That is their capstone. So as students are going through the defense management curricula, that 1 year journey is focused on developing the acquisition strategy for a solution set. And early on, when they go through their first milestone, they're trying to find and have identified a Title X sponsor customer to be part of that development. That's the difference maker that we have not had. And quite frankly, that's a difference maker for many of our industry partners, right? A crate is interesting, right? You're able to get insights, you're able to put some money towards, right? And you can co-develop and that type of stuff. And it's shared intellectual property, blah, 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 blah. But it's not a path to transition. It's not a path to revenue, clear path for revenue for shareholders and for a board. And innovation capstone with a Title X customer who's part of the process now is a different conversation. And that's one of the things that is a difference maker. And so defense management is piloting that now and looking to scale it to bring in, because when we talk about that with the fleet and force leaders, like, I want some of that, absolutely. Because again, it's about all the goodness, but making it transition into something they can use, right? And so adding that and really focusing and make sure we're putting a lot of effort into maturing, which is really the important part, is all this work on the front side, quite frankly. Because when you saw the fleet commander's problem and you saw the an acquisition professional's problem set, because you have already down selected and bought down the risk, you have the concept of employment, you have an understanding of the sustainment, you have matured the technology, right? And it's something that's ready to start to go and to scale. It makes this portion a little bit easier, right? But we try to do all of this right now, and we do it with varying degrees of success. So the point is that we take from the beginning, framing the problem, and the curation is not just the problems. The curation in many cases is curating the technologies that are out there already. If industry is moving at speed ahead of the NRD&E and the defense labs, how do we leverage what's out there? And the focus is on adaptation and adoption as opposed to new build, right? And that is a focal point. So curating the technology to go along with solving the problem. RDA's Pri 1 is mature tech and an operational problem. When those two things come across my desk, I'm going to vote buy. We can do that here and help build that strategy. And that's, I think, the difference maker. All right, I think that's my cue now.
I think it's a lot of great questions, but it is time for our break. If anybody else has any questions, I'm sure Captain will stick around for a couple minutes and answer them. So we'll do that, but if you need to hit the head or anything else, please take a 15-minute break. We'll be back here. This is a 10-minute break now. We'll be back here at 1500. Okay, our next speaker is Mr. Chris Fitzpatrick. He is doing a lot of great work in live virtual constructive, and he's building a learning laboratory that he's managed to bring in a lot of money, getting a lot of equipment for it, and it's really improved the curriculum since he's been here doing all this great stuff. So Chris, please take it away.
Thank you, very appreciate it. Welcome everyone. Great to have you at Moves this week, and really excited to talk to you a little bit about the LBC Learning Laboratory. So I think this actually fits in really nicely with Captain Sherrod's last brief, and to me, it just gives you a perspective. I'm a research associate at the Moves Institute, and working with Dr. Below, Dr. Grutzman, Dr. Darken, and also Dr. Denny Lester. We all together came up with a concept for this LBC Learning Laboratory, which I think is something that's going to be effective for us as a department. So just the agenda, I want to take you through what our strategic vision is for the Learning Laboratory, then talk to you a little bit about the purpose, look at the research thrust areas, talk about the foundation that we need to build, our network connectivity, and how that's one of the most important parts of building out our LBC Learning Laboratory. Talk a little bit about the organization, where we think that we should be connecting with for this LBC Learning Laboratory. And then also we're conducting a workshop with ONR coming up at the end of the summer or early part of the fall. I want to talk to you a little bit about that, and within part of the Learning Laboratory, that's something that we hope will potentially be an event that we could have annually. And what we're thinking about at that event is developing a science and technology master plan for LBC, but then revisiting that every year and looking at the kind of the progress that we've made, and then also how we could potentially change that master plan. And then finally, I just want to talk to you about some of my current lines of effort supporting the vision and how they would fit into the LBC Learning Laboratory. So the strategic vision for the Learning Laboratory is really to, much like Captain Sherrod had said, is to kind of create a place where academia, industry, and also the naval labs could go ahead and integrate together. And really what I think about in doing that at the Moves Institute is I feel like I'm the person that has to build out those environments for that. So in building out those environments, I offer the set of tools that are required for creating a learning laboratory, whether the tools be, modern air combat environment, VR forces, JSAF, JBUS, Amy, things along that line. Whatever students or faculty want to use, that's what I want to have available to them. Also, we're starting this process with building the learning laboratory with MB 4504, and that's going to be offered in the winter. So that was, as you may have seen the name of the course, the design and implementation of LVC events. And it's really exciting for us is, one of the things that you have to think about here at NPS is when we want to put on a course, of course, you have to have money behind that to pay the instructor to give the course and also prepare for the course. And since this is a brand new course in this area, we went ahead and got a resource sponsor for this. And our resource sponsor was TCOM and also OECIF. And OECIF is Operational Energy Capabilities Improvement Fund. So those were the two areas that are providing funding for that MB 4504 course. And I'll get into a little bit more about what's involved with that course and what we're planning on doing. But it is kind of exciting for us. So the purpose of the LVC Learning Laboratory, I talked a little bit about that integration of industry, Navy and Marine Corps, academia. And then also we have we're going to be focusing on Project Tripoli. So Colonel Addig, this actually kind of came from our kind of engagement at first is, I thought about, in building out or this design and implementation of LVC environments, I really wanted to recreate the example that you had done at 29 Palms. So what Colonel Addig had done is he had run some simulations at his lab at the 2MEF, or not the 2MEF, sorry, MAGTF TC. So MAGTF TC at 29 Palms. And then he connected MAGTF TC to range 220. He had out at range 220, he had some Marines that were wearing the warfighter augmented reality headset. So they were seeing virtual targets with that augmented reality headset. And then I think back at the MAGTF TC, he had some Marines wearing the JTAC virtual trainer, and they were calling 9 lines onto some of those targets that were out at the MAGTF TC. So part of MB 4504, the way we're thinking of it in the learning laboratory is that right now in our lab, and I think most of the students know that we're a closed laboratory. So, we're only kind of passing DIS data between each other. We're only passing HLA subscribed messages to each other and so things along that line. But our next step is that we want to get out of Room 212B and onto the campus, and then potentially all the way out to GIFIX or all the way out to 29 Palms. So that's part of what we're doing for MB 4504. So as you can see, I'm trying to expand the environment and expand the connectivity, and that's really important to us. So part of what we're looking at for, actually when we created, or when Lieutenant Colonel Addig created his event, he was using tactical cloud architectures as well as 5G communications. He was working a CRADA through AT&T for that, whereas we're looking at working with a company called Heine. That's the one that they are the ones funded over the OECIF funding, which I talked about, that operational energy project. So they're going to provide the 5G infrastructure, but then also AWS for this course, they're going to be providing the cloud architecture for us, which is kind of exciting. And they're going to take the students through some of the services that are provided by the AWS cloud, how we could potentially use those in a modeling and simulation environment, and what are some of the services that could make things a little bit easier. So it's going to introduce students to that, and that's something that we haven't had in the past, and we're looking to go ahead and expand that. In addition, with the AT&T 5G CRADA, I know that some of the AT&T engineers were doing programming to translate that 5G data, from DIS into 5G, so that it can be passed out to the headset. So that's another critical area that we want to introduce our students to. So the next area that I want to talk about is these research thrust areas. So I guess, I talked to Dr. Below. He wanted me to kind of think big about this LVC environment that we did. And the same thing when I was talking to Dr. Darken about it, is that we wanted to kind of think of a way that, how can we make an impact in LVC? So one of the things that we thought about doing was potentially creating a cruiser-like program here at NPS. And a cruiser-like program would be, well, if you're not familiar with Cruiser, they're funded projects that are briefed, you know, at the beginning of each month, and they really focus on autonomous systems. So, and what we'd like to do is have that same type of focus on LVC. So, so what I thought about doing was go ahead and creating you know, 5 projects where NPS students collaborate with industry, 5 projects where NPS students collaborate with research labs, and then 2 other projects where NPS students collaborate with academia. So someone else, you know, in you know, maybe at you know, Georgia Tech or Johns Hopkins University, along those lines. And so what we'd like to do is look at these research thrust areas, do research in those, and then that same environment that we're creating for that MV 4504 class is where we kind of do some of our demonstrations for all these projects that exist within these thrust areas. So network connectivity, this has been, you know, the most exciting part. You saw me get up this morning to thank Admiral Rondeau for pushing this forward, and also the Navy Modeling and Simulation Offices has helped me kind of push this STRAN connectivity forward for our projects, and we're going to get that connectivity by December of this year. So as I've been working on a project with NIMSO, I've been coordinating with China Lake, and we're going to connect with their integrated battle space arena in order to do our first test. And it's just a, you know, a connectivity test to make sure that we can pass data between you know, different naval labs. And then once we do that, what's going to be exciting is that I'm also starting to connect with the guys that do the NILEX exercises. So I overheard you know, some of the Marines talking about, you know, McWill is going to be doing a NILEX. Well, you know, I think you'll be if you follow this closely, you'll be seeing NPS soon after. So see, Major Yurkovitz looks pretty motivated about that, as motivated as I am. So no, this is exciting. So I'm really, you know, and if you guys have kind of tracked my progress with this, this has been something that I've been really trying hard to do. I don't want to be on an island anymore in 212B. I want to be out connected to the other naval labs. I want to be out connected to TRAC-MTRY group hacks, the battle space simulation centers at the MEFs, and as well as the you know, McWills and things like that. So I just want to say this is pretty exciting to us. The other thing that this connectivity to the STRAN will also allow us to connect to the Geometric Secure Network. So the Joint Mission Environment test capability will be connected with them. So that comes along with our STRAN connectivity. And then we can actually look at further connections to the NCTE, and then following after that, the J10. So those are things that we're looking for. So again, we're building our connectivity, but the STRAN is the start for us. So I talked a little bit about the LVC Learning Laboratory, and what I would be trying to do is to get, you know, I talked about doing those 12 different projects that we try to do, the ones with industry, academia, and then also other naval labs. And I try to be doing those at roughly 200K per 2.4 million. So I know I'm throwing some figures around, but this is, you know, I'm actually doing a lot of cold calling. I'm out looking for different sponsors, trying to see if there is interest in this, because I think, you know, this is a way for us to really, you know, make some impactful contributions to the naval research enterprise. So talking about that is in building this LVC Learning Laboratory, you know, the MOVES director will be working directly with the NPS president, reporting on our progress. And then we want to create an LVC Learning Laboratory Advisory Board, you know, someone that, you know, can help us pick the right projects that will actually be more impactful to the Navy. So this advisory board, what I kind of thought about is that I wanted to kind of integrate the commands that, you know, supported the MV 4504 course, because I think that was going to be really important for us. So that's why I thought the advisory board should be chaired by the commanding general of TCOM, as well as the OPNAV and 7, because I thought those would be the two, you know, to have, you know, the right fleet involvement for that. Then other representatives for this advisory board would be the Navy Modeling and Simulation Office, Marine Corps Modeling and Simulation Management Office, ONR, Marine Corps Warfighting Lab, and the Naval Warfighting Study, or the Naval Warfare Studies Institute. So again, I know that, it might look kind of presumptuous of myself to kind of think that, that funding may be available, but I'm trying, and that's what I want to try to do, because I think this would be really important. And this would be the best way that I could work closely with the students. I could provide the environment that they need, as well as also provide the funding that they need to do research with other naval labs. So the upcoming LVC workshop, I talked a little bit about what we were planning on doing for that and developing that S&T master plan, because I think, if I kind of, do a survey throughout the audience, I don't know if there is one specific document. There are STOs out there that might be available, but I don't know if there's a specific LVC S&T master plan. And please correct me if I'm wrong, but I don't know of one that is out there. But if there is one, of course, I want to get my hands on that. So that's one thing that we want to do during this workshop. In addition, we also want to align this workshop with end of the year reporting. So we talked about those thrust areas and then doing some of that research, but we feel like that research that we looked at that was in those thrust areas would be part of that S&T master plan. So of course, when we're presenting what we're thinking of doing here with the LVC Learning Laboratory and our thrust areas, we want the group that comes to that workshop to hey, we want to restructure these thrust areas. We don't think these thrust areas, are exactly aligned with the way the S&T master plan should read. So again, this LVC workshop that we're looking for planning in August or September is going to be something that, to me, we have a kind of a clean slate, and we can kind of, structure things a little bit better. But for me, putting this on a briefing the community, kind of makes it a little bit more real, and we can shift and restructure as needed. One of the things too is Dr. Darken this week has allowed me to come into his MV 4460 class. And what we did is we talked about a definition of LVC, and that was something that I thought was kind of exciting. And I wanted to share that with you. And this is the definition that we came up with. So what we came up with is a set of integrated interoperable simulation tools, including live, virtual, and/or constructive components to meet joint and coalition testing, training, and evaluation needs, developed to create a more collaborative, economical, safer, and secure conduct of events. So I just wanted to, kind of, show you a definition that we came up with, and then, get any impressions of that from the audience. No pressure or anything, but just to see, what you're thinking. And we felt pretty good about this one. This was a definition that we felt was easy to understand. It was something that, we kind of covered. We made a list of all the different components of LVC, and and I actually brought in the idea that I felt LVC was an environment. We need to say that it is an environment, not just simulation tool. So, but then I got kind of told that, maybe it is the simulation tools that we want to go to. So I, of course, for me, I just wanted to share with you, some of what we're coming up with, how we want to go about the workshop and provide, we just want to get everything on the table. Maybe it's foundation building, because I look at the LVC environment, I feel like all the tools are there. They just need to be restructured in a way that could potentially help out with training and readiness requirements, or, test and evaluation needs and things along that line. And sometimes so for example, like training and readiness requirements, sometimes I think, wow, to go through all the TNR grade sheets would be an absolute nightmare, but, it doesn't need to be done, and that's something that, we want to potentially look at. So, okay, so that was, kind of a quick talk about the LVC Learning Laboratory. Just wanted to, kind of stop right here. Any thoughts on that? Any inputs, or does anybody, have any, is that something that they feel would be needed, or something that, and I feel like NPS would be the right place for that. So, I'm not seeing any hands, but wait.
Just a question or an observation, I guess.
Oh, yes, sir.
Have you considered, so you have the organizational entities.
Okay.
Have you considered the developers of key modeling and simulation solutions as part of your team? I'm thinking, there are places like NGTS and MAST and SIM2, that are fundamentally, and that's similar for all of the services. They have a core set of capabilities, and they're always looking to improve them. And it seems like that might be a way to interconnect, the improvements they need on their side with some of the capabilities you have here to best effect for both.
Yes, yes, sir. No, and I think it's a great point. And so for example, last week I went to NSWC Corona Robin Hood Road, and one of the things I was looking at there, what are their goals? And one of their goals is for JSAF is to be more integrated with the EW community. So lo and behold, I'm starting to recognize, and so through some of our conversations, that the JSAF team is starting to talk to the NGTS team and think about, ways to better integrate the two models. So that's one of the things. The organization, I think, may be at too high of a level. Do we want to bring it one or two echelons down, to more of the developers, more of the technical group? Or
maybe commingled, or not commingled, but have both, right? I mean, have sort of a leadership advisory group.
Yes, sir.
And more of a model-based implementation. Because then you've got to get the best of both. You get the vision out of the leadership group.
Yes.
You get the connectivity with actual tools that will support that some of the initiatives that are being developed here.
Yes, sir.
Could benefit from meeting their requirements and vice versa.
Yeah.
So that might be one way we do it. They do it sometimes that way in other environments.
Yes, sir. No, absolutely agree. So thanks for those points. I appreciate it. So, Glenn.
So one, Chris, I would say, I think it's a great idea. I would almost phrase it as a modeling and simulation JIPX.
Okay.
Right? From the concept of there's an opportunity here of you bringing your simulation technologies and playing in this robust environment where you could get stakeholder and fleet feedback.
Yeah.
That might actually be something that would resonate with people.
Yeah.
The challenge with that for you as it stands right now, as briefed, is there's no joint.
Yeah.
You left the Army out.
Yes. Okay.
You left the Air Force out.
Yeah.
And the third thing I would say, what's interesting to me is that I know the Marine Corps is very focused on LVC.
Yeah.
However, I know the Army and I think the Air Force is moving away from the terminology of LVC because they have found that fewer and fewer people are understanding what is meant by LVC, and that there's no agreed upon definition across the Department of Defense for LVC.
Yeah.
And now they're moving towards synthetic environments.
Oh.
So does LVC Learning Lab potentially put you in a position of, we don't know what the heck that means,
Yeah.
so we're not going to participate?
Yeah, no, great point. So that's another area where I think the LVC workshop may potentially, put us in the right direction for that, or we might start getting community input, and that's why I'm trying to get community input now, and this is why this is great. The other point I wanted to make is last week I was at the Joint Staff J7, and they have the JLVC modernization program, which is really, I look at the way that we're going to make, LVC work collaboratively between the communities is through this, the JTT, the Joint Training Tools, and making sure that everybody's going out and grabbing those, using them within their service-specific LVC events. And I think, for me, for like a small scale, deployment of, LVC environments for my class, they're probably going to be pretty service specific. But of course, as we connect to the STRN and look at larger connectivity, we're going to get a chance to be more connected to kind of those joint events. So yeah, I
You
do.
do have students that aren't native.
Yes,
Right,
yes.
so
Oh, yeah.
you do need to, I mean, they're close to Marines.
Yeah,
But at the same time, the Army students may feel isolated. And then if they feel isolated, then the sponsors may feel isolated, and potentially lose students. So making sure that you make sure that the hooks, or at least the caramel candies are out there to follow. To the right place where you're leading them where you want them to go. Right?
Okay. Yeah. So kind of my first revision of this would be that, integration of, all four communities and the international community as well, because we do a lot of work with NATO, CWICs and those exercises. So here's just a listing of some of the projects that I'm working on right now. And I think I still have plenty more time. So these are the projects that for right now I'm looking at, and I'll go through some of them, not all of them, just looking at time right now. So we have ONR Tech Solutions, a small unit mission planner. Major Hickey's going to go ahead and brief that. Improving identification of ship tracks using a data-driven approach. That's an NRP project where we're looking at weather patterns and how those are able to display different ships moving within the Pacific and other areas throughout the globe. Enhancing the USMC VTOL family of systems. That's an NRP project that we're looking at. I work with the systems engineering capstone students on building out simulated scenarios for that. Same thing with another system engineering capstone, looking at task saturation for EAVO, using simulations to look at how to run 9 lines and how to task UAVs, whether they're teleoperated or if you're just providing some different control inputs to those. Modeling naval presence, that's working with the Sagamore Institute. Cruiser interactive synthetic environment to evaluate zero carbon UAS launch platforms in the Arctic. So that's one of the areas that we're interested in modeling. NIMSO, integrated naval testing, training, and evaluation environments. And I've got a slide on that, and I'll talk about that a little bit more, where we're evaluating JBus and Amy and what are some of the differences between those two interoperability architectures. And then the Operational Energy Capability Improvement Fund, airship deployment for DoD missions in contested battle space, and then as well as the MV4504 course. And I've got a little bit more information that I want to talk to you about there. So this modeling of the value of naval presence. One of the things that we wanted to look at there is, what does it mean to be like a carrier in the in the Pacific, or what does that value actually mean? And then if they're traveling with a coalition ship, what does that mean? Like, is there a specific number value that we could give to that? And if you look at, this is probably one of the hardest problems for the CNO. So if you look there, and this is from 2022, there's 293 deployable ships. And again, that number's, in changing. Total ships underway are 64, deployed ships 41, and deployed local operations 23. So you see that, covering that 134 million square miles of ocean, is with, 64 ships is almost an impossible problem. And then when the Arctic Ocean, starts to thaw, the same thing, it adds 5 million more square miles to cover. So this is an area where we've written a paper again, and we're looking at, potentially building a model for the Sagamore Institute to kind of look at this problem. So this is one of the research areas that we're looking at for the next year.
What are you actually measuring with that problem statement? I mean, not every square mile is equal in value and import to every other square mile.
Yeah.
And, the value of allied ships and presence and partnership, and what are the metrics to determine value? Economic prosperity up, cross-border incursions down, FONOPS, what is it?
Yeah. So that's going to, obviously, it'll probably be very similar to maybe a lot of the wargaming playboards that are there, where some of the, the grids that get closer to, say an area of interest, would be worth a little more. So that's an area where we want to put value. Obviously, looking at the different levels of ships, one might be worth a little bit more than the other based on, who's deployed with it, maybe what is it being reported on social media, things along that line is kind of, one of the areas that we're looking at to give an evaluation number on something like that. In addition, are you traveling, with coalition ships, moving through? Is it 1, 2, 3, or 4 ships? Things along that line. So it's again, we just kind of wrote a paper about what our approach would be, and we've been selected for funding in the next year to do that. So I think it's an emerging problem, and hopefully at next year's moves open house, maybe we have a little bit more clarity on what how we're going to do that evaluation, and are we going to use large scale simulations to do that? Are we just going to focus on maybe just the Pacific, or maybe just areas within the Pacific Ocean for that? It might so there's certainly a lot of open questions. So I don't think I finally answered your question, because more research to be done in order to provide the correct answer. So. Okay, so interactive synthetic environments. This was something that we had done for Cruiser, looking at, we looked at Eielson Air Force Base, and this was for the launch of airships to, provide some support for ISR of the Arctic. Again, once it thaws, we're looking at mid-century during the summer months for that to happen. And the same thing, we looked at Thule Air Base in Greenland up at the top, and we actually once we ran this simulation, we actually, after a week of running the Airlanders through this while they were launching UAVs, Scan Eagle UAVs is what we were launching from them. We actually got coverage of a little over 50% of the Arctic when we were flying these specific routes. So I think there's a lot of value in modeling and simulation. When you're building out your scenarios, you're going through a pretty big kind of planning process in order to get to the point where you can come actually build out your scenarios. So I think that's something important to consider. So that was some work that we had done for Cruiser. And that's the integrated naval testing, training, and evaluation environment. So this is actually one of my biggest project for this year, working for the Navy modeling and simulation. 2 minutes, got it. So 2 minutes, I'll hit this quickly. But what we're looking at is evaluating the differences between JBus and AMI. So the AMI is the Architecture Management Integration Environment, and JBus is the Joint Simulation Bus. And what we're trying to do is, AMI is getting to the point where they've just released version 2.5. They're doing time management with that, where they're managing differences in time between the RTIS as well as TINA objects. And in doing that, we want to go ahead and see if we can plug in JBus into the same environment where AMI is being used, to see if are we funding two interoperability architectures that are being used within the DoD. So again, that's one of my main projects for this year, and I'm finding that in the EW environment is where most of AMI is being used right now. So that's where I'm trying to push JBus into that environment to inform NMSO leadership as to its specific capabilities. And then I just wanted to kind of show actually, I'll go ahead and end there, and just because I've kind of covered the MB4504 quite a bit. So if there are any questions, I know most of you got a chance to ask your questions during the brief, and I think I'm at my time. So Kirk, when do you sleep, man?
Yeah, of course. Ask him during the session.
Get plenty.
Okay, well, thanks a lot. That was great, Chris.
All right, fantastic.
Thanks. Well, I don't really need to introduce the next speaker because he's already spoken, but Dr. Chris Darken does more than just being the academic associate. He also does a lot of great AI research, and he's going to talk about that for about half his time, and then Lieutenant Colonel Scotty Black's going to come up and talk about some of the work he's doing.
Keep him in a less than half if I can, and in order to do that, I won't really speak well to these slides, so we'll leave them up there, and they'll be posted. And feel free to ask questions about the details on them. I won't really have time to talk about them, but I'd like to just give you some headlines on what we've been doing here on campus relating to AI for simulations specifically. And what I want to do is really start just with an obstacle. I want to talk about one obstacle, not the ones, the cultural ones we can't do anything about, but the horrible technical obstacle, which is just that what we're asking the AI to do is very unreasonable. That's the short message there. Okay. So AIs exist in a game tree search space where we think that the starting state of the war game, everything you see is one point at the top of that tree. Every possible state you can get to just with one move. In our case, we have a war game where red moves and blue moves and then red moves and then blue moves. So after one move, you have a certain number of states, and then the next move happens, and each one of those states bifurcates further. Okay, and if you have a very simple model, I won't dignify it with the name war game. 5 by 5 hexes, tiny. 3 infantry units on the top, 3 blue infantry units on the top, 3 red units on the bottom. We figure out on average, each state has 64 child states. So you start in one position, blue makes his move, you're in one of 64 new states. Then red makes his move, you're in one of 4,000 some child states. Okay, it's growing by a factor of 64. So if we were to draw these states, just each one only gets 1 pixel of real estate on this screen. We start off with 1 invisible 4K screen pixel. We go to 64 child states. That's maybe a line segment about this long. Next, we're as wide as the screen. 1 more move down. I need 64 screens wide to represent the thing. By the time you get 3 turns into the game, I need a monitor that won't fit between here and New York City. Okay, and that's not a full-scale game. Okay, that's a tree, and what we're asking the AI to do is find a good trajectory through the tree. Okay, so clearly you don't get there by an exhaustive search of the tree. That's not credible. Okay, and most of the algorithms that we're working on these days, whether it be reinforcement learning or game tree search specifically, do a kind of a random search through the tree. Okay, so 2 big headlines from research is that we need to make use of parallel computing, i.e. cluster computing, to do anything with certain ones of these random algorithms. So this is one that I've spent a good part of the last year working on. It's Alpha 0, developed by DeepMind as an improvement to their AlphaGo world champion Go playing algorithm. It's a good algorithm. It's nice, it's clear, and it's sensible. I think it's a best of breed sort of algorithm. And serial implementation just is not cutting it, except for the most tiny problems, smaller than the one I just described for you. So one of our approaches in the next year is just parallelize the thing. Go on the cluster. You use different technologies for that, Ray or Python multiprocessing. Will that make the difference? It should, because it was used. It can solve Go, which is harder than these tiny war games. So I hope to have a better result, a better story to tell you about that next year than I do now. But that's one of the things we're actively working on. Now, the other thing is, if you can't search this tree, wouldn't it be great if someone could tell you where to look in this vast thing? Okay,
And any simple algorithm that you might build, here's one that I've spent time thinking about this year, but my main point is not this specific algorithm. I'll tell you a few things about it. The main point about it is just that it does one specific thing. It's very hard coded. It's not a traditional scripted algorithm. I'll tell you what it does, okay? But it just runs, it doesn't really make choices. It's kind of, it's what it's meant to model is what I would hope any of us would do if I have an operational picture of the kind you're familiar with, and I say, okay, I'm going to ask you what to do in this operational picture. Here it is. Okay, that's all I'm going to show you. What do you want to do? All right, you would still, from a very brief momentary exposure, you might get the idea that, oh, I see a density of blue forces in the north. We probably should be attacking in the north. We probably need to think more about force preservation in the south. You'd be able to say more than nothing. And that's what I want to call reflexive behavior in the top. That's what I'm trying to model here. So this is a model that does reflexive behavior really without anything that's identifiable as normal AI from students who have taken classes with me or if you've done some reading on the internet. Okay, it really all rolls up into a formula that you then take derivatives of to produce a gradient, and each unit moves in the gradient direction. So even at the level of moving each individual unit, there's no, should I move north or east or south or west? Which is the best? You don't do any of that. You take the gradient of this objective function that says, hey, if you want to do the right thing to do, and what we're doing specifically is just looking at differential attrition in this model. If you want to maximize the rate at which you're killing red and minimize the rate at which red is killing blue, you move in this direction. Now, you want to know how to move the other guy? Same story. You take the gradient with respect to his position. Okay? So you can get some behavior from this. Again, my main point is not about the specific algorithm, but I'll show you if it'll load up. We'll see if I can show you that it does some sensible things. And it certainly understands local superiority of force. And I think. So what you see here is some oscillatory behavior. Let's take a look at it a little bit carefully. Okay, what you'll start out with, if you look very close in the middle, you see a 2-on-1 matchup of blue versus red. Okay, so blue comes in to kill red because that's how you maximize differential attrition. But it's only momentary because right behind, here comes the big red force in behind, and now blue realizes, okay, now I need to be defensive. You'll see he'll change direction and move the other way. But then blue's reinforcements come in, and now the tide shifts again. Okay, I'll give you another view of it. Blue, then red, then blue. You get the idea? All right. You can do a lot more with it than I'm going to talk about here. But that's an example of a simple algorithm. Now, if you go to this vast game tree that we're talking about, this is an algorithm that doesn't spend any time looking in the tree. It just picks the one branch down that it likes. Now, you might like this algorithm, you may not like this algorithm, but it sure is easy to implement, and it's super, super fast. If it turns out you do like it, you might say, hey, I've got this vast tree. I don't know where to look in it for good behavior, but here's one specific line from top to bottom of the tree. Maybe I'll look around that line. Okay, it would give you a way to focus your search. So that's something that I'm very interested in going forward. Let's see if I can go back and find my talk. Maybe, maybe not. Over here.
Just to the left of the one that you're on. 23.9.
23.9 over here?
Yeah.
Ah, thank you. Rescue. Okay. All right. Beyond that, just a couple headlines. So some interesting master's theses are coming out this year. We do Navy work with these simple models, even though I don't often show it. Joe Koval has a very nice thesis where he's done a big bake-off of multiple naval scenarios, multiple algorithms of the type you have heard me talk about. And that should be done within the next few weeks. Matthew Finley I'll give him credit for kicking me in the behind and getting me to finally start thinking about parallelizing these algorithms. He managed to show a between 10 and 100 times speed up going to a cluster from a simple single CPU for traditional reinforcement learning. That's a very nice result, and he's got more results in his stuff. But what I really would like to have you see is what Scotty Black is working on for his dissertation. So you might, why don't you come up, Scotty, and we'll try to switch over to you. And I'll stay around for questions later, but right now I want to have things over to Scotty if I can. So. Okay, there we go. I don't know how to advance. I'll let you figure that part out.
That's not going to advance them.
It's not gonna answer no worries. Please stop. Right. All right. So Scotty Black, I'm gonna go really quickly because we only have a limited amount of time. We're trying to squeeze two different things, two different briefs within a single time slot. But and I got to take off today at 4:30, so you might not be able to catch me right after this. But tomorrow I'll be around all day. If anybody's interested, I would like to talk more about it. I won't be able to do it justice today. So rather than tell you the importance of AI for wargaming, I want you to imagine instead of in the business of fighting wars or warfare, we're in the business of writing essays, both quality and quantity. And our competitor, who's also participating in this space, has a capability called ChatGPT that we just don't know about. You can imagine, you can see how very quickly we would be put out of business, probably within days, without knowing what happened. Even if somebody told us on week one, hey, it's ChatGPT, it's an AI, we wouldn't be able to develop it overnight. And that's why it's important that we start investing more robustly in this type of technology, because if the balloon goes up and the adversary is able to outcycle us in decision space, by the time we're able to do anything about it, it might be too late. And the idea, as you saw on the previous slide, my research, hopefully, if it's successful, is to try to get at the superhuman wargaming agent. But that's not the end state. The end state is human-machine teaming piece. I don't believe, especially within simulation or wargaming, even if we have a superhuman agent, that we would be able to, Scotty Black, wouldn't be able to defeat it, because I could probably easily defeat it by just changing the rules of the game, right? And we see it in Iraq, Afghanistan. We have these ROEs, but all it takes is for someone to violate the ROE. For example, we shouldn't kill women, or we don't think the enemy is going to kill women and children. If they do, that changes the game, right? As humans, we can adapt to that really quickly. As artificial intelligence, machine learning, they see it as an outlier. Probably never happen again. That was a 1 in a million chance, and it'll continue to go on. That's why this human-machine teaming, I think, is going to be critical. So combining the human with the machine, and not to get machines to think like humans. I personally am not interested to create an AI that can fool me into thinking it's another human. I want the machines to be really good at what machines do, and humans to be really good at what humans do, to include their biases, which we kind of developed over centuries, if not millennia, that are very valuable. So that's kind of the ultimate end state. It's a decision advantage when it counts. And this is from beginning to end when we think of wargaming. Everything from plan generation, coming up with COAs, to wargame those COAs, to execution on the battle space and the command centers, making decisions real time, taking advantage of what simulation and AI can do for us. I won't go into detail because this would be time consuming, but keep in mind there's a lot of folks working, it's relative. There's not a lot of folks working in this space, but there are quite a few actually, if we start looking around, who are working in this space. Everything from the top and government research to Chris covered DeepMind with AlphaZero, to some of the other superhuman game agent or bots that they've been created for poker, Go, chess, etc. To some of their real-time strategy games, and all that work we are leveraging here at MPS, and they're leveraging throughout the DoD research. So it's not that we're not applying these, or we're not solving problems because we're not applying these techniques. It's a problem that's a lot more complex than the game of poker or the game of chess. So my specific approach is going to be hierarchical reinforcement learning, but that is not by any means the solution, in my opinion. That is kind of the framework I think is going to be a bigger solution. And for those who are not familiar, reinforcement learning in the simplest terms, it's just learning what to do. Taking the environment or the state space, and that is your kind of input, and then taking an action based on that. And it doesn't require labeled data. A lot of time when we think artificial intelligence and machine learning, we automatically jump to supervised learning. It doesn't require human data. It uses simulation to generate that data. Now, given now it's constrained to the fidelity of that simulation or the quality of that simulation. So those answers that that's providing us has its own assumptions, but it is valuable. A hierarchical approach essentially is looking to kind of break down the problem like we break down the problem, especially in the military. At the operational level, if we were to go to war, defend the island of Taiwan. At the strategic level, they're making decisions. They don't need to know what's going on, whether all the Marines have the right rifles or are putting on the right colored boots. They don't need to know that. Same at the bottom. Those Marines or sailors or soldiers kicking indoors, they don't need to know what Russia might do in this scenario. They need to focus on their specific task. And that's all that hierarchical reinforcement learning is trying to get to, is breaking down the problem, making that intractable problem more tractable so that we can potentially compute a solution. I'm not going to spend much time on the slide. Just know the intent of my research is to try to scale AI to deal with the complexity of these large state spaces that are characteristic of combat modeling simulation, specifically in support of wargaming for analysis, training, education, plan development, or real-time execution. There's three kind of big focus areas, and I want to try to leave questions for time for questions at the end, and we can back up slides if you want if you have a question about a particular slide. But three kind of primary research areas, kind of just to divide this into threes. The first one is HRL, hierarchical reinforcement learning, agent architecture. What does that agent look like now that we're going to use a hierarchical approach to this? As well as what that HRL training framework, what is that going to look like? That's going to be on the next slide. And I'll talk very high level to that, but happy to go into detail on the sidebar. The second research area, I think it's just as important as the first, if not more. It's how do we abstract the space? How do we represent the space to an agent at different level, at the operational level, to high level? How does that agent see the space so it can make those operational level decisions? And how do the lower level tactical agents see the space? And I think that's very important. Right now, a lot of the reinforcement learning that's happening, everybody gets the same amount of information, and we already know that that is very hard to compute and often an intractable problem. Oh, and the last one, this is what I'm very interested in. So right now, we're using the lateral combat simulation environment. It allows us to iterate really quickly, learn fast, fail fast, and be able to retweak or figure out another way forward. What ultimately we want to do is scale to some of these medium to higher fidelity. Command PE is just the example. That's commercial off the shelf, medium fidelity simulation. It's kind of 80% solution, multi-domain. But you can think of others, whether it's Combat 21 or AFSIM, something that's a little higher fidelity, to see if this concept, this framework can still be applied to the scale. So for the research progress, I just want to hit a few high points on the research progress. So it's kind of a general framework. And, I'm taking a very kind of agile, mindset through this. It's kind of fail fast, get it faster. So this is what it looks like yesterday. It doesn't look like this today. But essentially what we're trying to do is take a hierarchical approach. So if we go from left to right, that's kind of the hierarchy. So you have the kind of the commander at the highest level. It's going to take a course observation of the battle space, and it's going to pass down. You can think of sub goals as orders. Hey, I want you all to take a defensive mindset, offensive mindset. When should you terminate that? When should you come back up to me for another decision? The manager, you can think this kind of regimental level. Levels here are kind of arbitrary. Just think about a hierarchy piece. I have 3 battalions. This battalion go this way. This battalion go this way. This battalion, you hold the city. All these decisions are being passed down to the ultimate, down the agent, the actual entity on the game space, on the game board, or the in the simulation, to make an actual decision on what to do. When I say a decision, I mean a discrete action, do something. And that's kind of the idea here. Key to this, but kind of in the corner, this abstraction piece. And then, which I'm working on right now, which I'll give you a little bit of update on where we're at right now. As well as I think key is going to be this intrinsic reward engine. And that's really going to be able to train these, each of these different layers appropriately. So this is kind of this is the multi-model framework. This is kind of step one of what we did. And this had very surprising, very good, surprisingly results. I was hoping for at least as good as our best agent. It ended up outperforming. I'll cover the results on the next slide. But just really quickly, so what we have is a score prediction model. So it's supervised learning trained models of each of these behavior models. So given this, how do you think this would the agent would perform overall? This kind of framework is kind of inspired by kind of the decision theory that Gary Klein talks about with expert decision making. That we have a heuristic. We're just going to go down a list, go through a heuristic. Would this work? Kind of imagination based, and if it works, we kind of go with this. It's a little more than that. But we differentiate it from kind of ensemble learning, that we're not combining decisions. So it's not necessarily the wisdom of the crowds approach, where we get all these experts together and we go with the average. which does work. This is really differentiating behaviors and going with the best one. And the interesting thing about this approach is instead of having to worry about what quality of models we put into this multi-model, we could just put whatever, from what we know so far, whatever we want. So here's an example. So we have this multi-model 8 that's composed of 8 different behavior models. You can see these are individually how they score on the game, over 100,000 games. So you can see these script agents do pretty well on their own. And that's kind of so far the state of the art that we've seen. RL agents, granted, don't take this as this is the RL agents that I trained specifically for this scenario. So we've done much better than this 21 compared to the best of 80, but just for this scenario. But you see these ones that I trained, not to maximize game score, they exhibit certain behaviors, did really horribly. So you would think that a multi-model composed of all these best ones would outperform one composed of good ones and horrible ones. But we see the opposite was the case. The multi-model that had the most outperformed, the best individual one. So that was a very interesting finding of this specific project or part of the research. What I'm working right now is this abstraction piece. So how do we take this? And this is kind of an example. This is, I can't remember. This might be a 10 by 10 game board. Very hard problem to solve. Actually, it's going to be on the next slide. So how do we take this observation space? And keep in mind, this is just one layer of 17 that we have right now. But this is very computation. This is very intensive. It would take forever. A lot of the stuff that Chris Darken talked about, parallelize, and maybe we'll get to a solution. But how do we take this space and still make it meaningful for the agent without the need, but still collapsing that space? So what we use here is kind of localized observation. I won't go into detail right now. This is a 5 by 5. I think the right answer is a 7 by 7, which I'm currently running the experiment right now to verify that. But the bottom line is what we see is collapsing, taking this space, collapsing this space. We can see that the agent is able to learn. So this green line down here is an agent taking this entire space and trying to find the right answer. Again, it's more than just space. This is multiplied by 17. It is learning very slowly, but you can see it's not learning very much. And this is kind of a mean reward. It's not necessarily the actual performance. It's how we're rewarding the agent, which based on this reward system, they're going to correlate very likely. But you can see this 5 by 5, taking a 5 by 5 observation of the 10 by 10 space in a localized manner, it can learn. Now, again, it's not finished yet, so I don't know how it's going to be performance-wise, but this finding to me is very interesting. So I'm running out of time here. I want to leave a few minutes for questions. The other big thing I want to highlight, this is not necessarily a reflection of me by any means, but this is a reflection, I think, of the topic. It's gaining more momentum within the DoD, that it's starting to gain, starting to be accepted, or starting to, a lot of folks are starting to are beginning to talk about it more, at least than when I first came to NPS, at least my perception of it. You can see this left panel, besides doing my dissertation, a big part of what I want to do, especially leading NPS, is try to market this idea of AI for warning, trying to convince folks that we need to invest more money, more effort into it. So keep in mind, this kind of left side here is kind of my marketing plan to show the value. This top side is more hey, this is what's going to take the likely graduate for with a PhD from NPS papers. And then the good thing about that, the research is I think we're able to break it down into discrete little pieces with findings that can be peer reviewed throughout the whole process. And then this bottom part, the last thing I'll leave you with, I think is the most important part. These are just a few of the collaborations, the more formal collaborations. There's a lot more collaboration that I'm working with, and new ones that are appearing now. Folks at George Washington, very interested researcher there. Folks at Indian Head, Naval Warfare Center, Indian Head. Tracking some DARPA programs, learning from them, giving them lessons learned from ours. But I think this is where we're going to accelerate. This is what Captain Sherrod kind of brought up. Collaboration with industry. I think this is key in collaboration with other DoD agencies. This is really what I think is going to solve the problem, not what Scotty Black does here. So I encourage you, if you're working in this space or interested, please let me know. So with that, I kind of went a little longer than I wanted to. I'll open the floor for questions for either myself or Chris.
Have you got any input from the mentor side as where they went to this, something like that with McWhack and all that stuff?
Yeah, so, yes, so I'm talking to, Tyson Cackley, regularly on this. They have their own priorities, but the AI for Wargaming is their #1 NRP submission. So, Marine Corps, Wargaming Analysis Center, McWack, through Marine Corps Systems Command, submitted 5 topics to the NRP. #1 is AI for Wargaming. And then, I can't remember what the other ones are, but also this is important. So the answer to your question, yes, and they see it now, becoming a priority for research.
Give you time for one more.
Artificial superintelligence.
Yes.
What is that like? What does it like? What's the status of ASI?
Artificial superintelligence.
Yeah.
I don't
I
think.
just heard of it. So it's artificial intelligence. Does it model them? AI?
I don't know if they're kind of getting at the generalized. I don't know. That's the first time I've heard that term. So I don't know if it's generalized artificial intelligence. Everybody has an opinion on that. I won't share my opinion on that. Yeah, I think everybody's working towards that. We'll get there someday, probably, maybe.
Are we anywhere with that? Like, or is it reality or just like fiction?
So I think it depends. I think it depends on who you ask, right? Especially with things like ChatGPT coming out, folks would start arguing that maybe we're getting closer, right? Because there's an appearance of understanding context, an appearance of deeper understanding of the material. But other folks will look at that, you know, some folks are a little bit more understanding, saying it's just giving the appearance. Now, don't get me wrong, the appearance, if we're outcomes oriented, right, that's all that really matters, the outcome, right? What's actually happening on the hood, does it really matter? It's giving you an answer that takes that into account. So that's why I think it's a very contentious topic, at least from my point of view. I think we're far away from that, but we may be closer than we think we are based on some of the recent breakthroughs.
Thank you.
Awesome, thanks.
Great, Chris, guys, thank you very much. Once you come through here are great, and you're going to see one of them right here. Mike, when did you graduate?
2011.
2011. So
It's been a few years.
yeah, it has been a few years, and so
What's that?
You also give us our deputy.
that's true. It's not one. There we go. Sometimes. Sure.
In my experience.
Yeah. So we need to talk to that, but no.
All right.
And so without further ado, Mike.
Wow, we're just blowing through nap time, aren't we? Everybody know that quote? My favorite quote? No? Nobody knows that reference. Arrested Development, Buster. Tough crowd. Okay. Well, I was asked to come here on behalf of Randy Verde, Colonel Verde, how do I get rid of this? The EMSO director. And so I called him this morning and I asked him, you know, what would you want to transmit? How many Army students are in the class this year? We have one. Are they here? No, none of the students are here right now.
Taking care of Wargaming.
Okay. So what did he say? For one, to moves, he wanted to reinforce the Army commitment to supporting moves. Absolutely committed. And if you look at the history of the Army students that have come out of the moves program, it's pretty significant in terms of impact to the Army. So we have our only Sims general officer was a graduate the year before me, Brigadier General Glazer, who came here. Jason Caldwell just retired. Dave Parks just retired. One was the National Simulation Center director. The other was the Joint Multinational Simulation Center director. Dr. Hodges, who is here, obviously his impact, both as proponent officer for the 57 functional area was significant, and many countless others that impacted the Army and the Joint Force after coming out of this institution. So I think the Army has nothing but great things to say about moves and a commitment to it. I certainly learned a ton while I was here, and I always look back on my experience here highly. So real quick, I know he usually covers when he's here what 57s do. For those that don't know, I'll be very brief. So the Army has a functional area in which we specialize in simulation operations. I think we're really unique in that. The other services manage it a little bit differently, but we have a functionary, which I, since I left the infantry branch and became a simulations officer in 2009, starting here at MPS, have gone into, and now I'm just a simulations officer with a basic branch of infantry, but I haven't touched the infantry in about 13, 14 years. So there's that. So what does he want everybody to do in terms of, especially the Army folks? So that Army student, I look at him right now. We need to solve Army problems. So what are the Army problems? Well, I'll cite one visit I recently had from General Anderson, the J7, Joint Staff J7, and we briefed him on wargaming. And one of the key things that he keyed in on was contested mobilization. And so when we look at mobilizing the force across the compos, the active force, the National Guard, the Reserve, we don't have a lot of great models that have really looked at that. And so when General Anderson heard that, it really resonated with him. We're working on a war game. Major Mahan's back here working with First Army. When is that exercise? When's that working? October. Okay, in October, executing that. But there's certainly, even that is a fairly simplified model. There's certainly a lot more to look at when you look at mobilization in the current competitive environment of how we actually execute that. So definitely something to look at there, probably across the joint force. In terms of what I want to talk about today, I found it interesting that when I got to MPS and I heard simulation in my mind, when I heard the word simulation, it did not involve analysis at all. It involved training and education. And so why is that? Because I think the Army culture of 57s, and this is what is hard to understand outside the Army in many ways, the 57 side of the house is very training and education focused. Not that we don't do analysis, we do. And then we have what are the ORSAs, the operational researchers, like the TRAC-MTRY director came in earlier. Those folks focused on analysis. But I would say culturally, we're very focused on training and education in the Army when it comes to the word simulation. And so I want to address a few things that I have learned since I left here as I reflect, because Colonel Verde said, I don't care what you talk about. And so what I decided to talk about is what do I think about as I look back on my career, as a 57 in various echelons and various types of units. What are the main thoughts I have as I went and applied simulation in the real world on a day-to-day basis with the force. So I'll cover that. But first, I just want to talk a little bit about the War College. Who understands what a War College is? So I know my audience here. Okay, some of you. I'll go over it real quickly. So bottom line is we have officers in the professional military education that pass up, and our majors, lieutenant colonels, their whole career, they've been focused mainly on the tactical level, some operational level stuff, but really how do you take officers in terms of education and transition them from a tactical operational level way of thinking to an enterprise level way of thinking. And that's what our war colleges do across the joint force. And the Army War College, what does that is the School of Strategic Land Power for Army students, actually Army, all services, and about 80 international students, almost a quarter of the student body being international. That's the School of Strategic Land Power. Where I come from is the Center for Strategic Leadership, mainly focused on strategic level wargaming. And we have you can see the other departments there across the schoolhouse. But suffice it to say, the so what of this is that there's more than just the schoolhouse that's doing the Army War College work of converting students from this tactical operational mindset to a strategic mindset. There's a lot more work being done there, including PKOSOI. I heard talk about peacekeeping earlier. Those are great folks to partner with. We educate our general officers there through the Army Strategic Education Program. So a lot of stuff going on there at Carlisle Barracks. All right. So the big points that I thought about as I was asked to address this body that I departed from and graduated about 12 years ago. So the first one is, how do our simulations tool, how are they applied in training education matters more than the tool itself. So what I mean by that is we focus, I want everybody to just kind of step back from what you do on a daily basis in academia. And this is not to disparage academia by any means. It's important work. But how does what you do actually get applied, particularly in training education, to improve units, to improve officers, to improve non-commissioned officers, and the force as a whole? It has to be integrated. So one of the programs I manage is I work with different graduate schools. NYU, University of Washington was up 2 weeks ago. There's about 15 prestigious graduate schools across the country that I work with to do a negotiation exercise. It's an international negotiation exercise. We have several scenarios. And there I've seen, as I've gone through these schools, that you would think all kind of operate under the same mindset, that they would take that simulation we provide them and do it the same way. But I'll tell you that when I went to the University of Washington, here's a situation where you go in and they execute this exercise, having done a whole semester of study preparing for that exercise. And then, oh, by the way, they had a whole week worth of curriculum following the simulation exercise where they talked about the results of that exercise. Compare that to another school that I won't mention that did no preparation whatsoever, showed up the exercise and thought that was the end all, that the simulation would provide them that training, and then they left and departed with really no review of what happened. Both very prestigious universities. One handled it one way and got a tremendous value out of it. The other, I can't really say that they did. And so I've seen this with military leaders throughout the course, where we hand them a simulation capability and they think that is the end all of achieving training. So I think there's really two types of leaders out there. One that will ignore simulation completely and don't think it's value added. And the other that thinks the simulation is the end all to what they're going to do. Just give me a simulation to do it. And one example I'll give, a 3-star general, one of our smartest, became a 4-star before he retired, came up to me and asked me if we could produce a simulation that could develop leaders. And I said, sir, that's a human endeavor. We don't develop simulations to develop leaders. What is it, part of something bigger? Like, no, I want you to develop a simulation that can train leaders. Sometimes that's the mentality we have to face when we talk about the simulation tools. So why am I saying this? Because I think the onus is on us as simulation professionals to build tools and have tools that will always be executed, used within the context of some type of learning or training that makes sense. That when you think of the tool you're developing, where does it sit in that continuum of training or education that it can be used? And if you start thinking of your simulation, other than maybe part task trainers, but even then I could argue something against that, how does it fit into something bigger? Because you're one part, you're a tool, you're a hammer, and we're building a house. And so think of your simulation that way. So that's one thing I've thought about for a long time. And I think we as simulation professionals err sometimes with that. I know I did. I know I had times where I thought, well, we're doing this exercise with this simulation, this should be it. But really it's about the design of the exercise. Second thing on that same topic is I have seen low overhead tools get used more in the Army than anything else. So we spend a ton of money on these exquisite, massive simulations with great combat modeling. They're validated. You go through the whole VB&A process. And yet the most effective training exercises I saw sometimes were using very low overhead tools with very rudimentary algorithms. I think there's value in that. And I think we, as simulation professionals, we kind of, to our own demise, ignore the value of those kind of tools because we are attracted to the more fanciful algorithms and the bigger stuff. But I would argue that kind of tends to detract and cause the problem I talked about previously in many ways. The more fancy it gets, the more we see that as the end-all solution. Okay, second bullet up there. Does decision-making of itself, if we repeat it, if we practice decision-making, does it make us better decision makers? I don't know what the answer to that question is. It's rhetorical, but I'd like everybody to think about that for a second. Like, if you continue to make decisions, is it because you become a more effective decision maker? If you're presented with more scenarios, kind of like an AI, like we talked about, we're presented with more and more, are we actually better? So it's kind of tied to the first one, but how do we actually make better decision makers? By presenting them decisions. There's obviously got to be some methods that we go about to do this. You know, obviously one is the feedback loop. Somebody talked earlier about in that decision game doing the debrief. That's the kind of thing I'm talking about. As you revisit that in an AAR, that becomes critical. So what this means is that as we're developing simulations, they have to be built with that end in mind. They have to be built with the capture, the AR thing. That feedback has to be built into whatever we're building as a simulation, or we're back to the original problem I talked about, where that simulation exists in isolation. So feedback loop. Then we talk about wargaming. So I define wargaming as a notional plausible scenario in which players compete using decision making. Where I am at, we use a lot of analog war games. Do we have one simulation technically running, Bill, in our department? 2 pretty rudimentary ones. We do a lot with wargaming. This is a lot of what came to mind as a simulation officer walking into a department that has a bunch of paper cutters and printers and 3D printers and all this other stuff. It kind of brought me back to the core of what wargaming is. Like the core of wargaming is about creating this set of rules in which people compete with decision making, but just like a simulation, it exists in some bigger context of learning and education. And so if the decision making is what's making that war game, how do we make sure that decision making is used properly within that? The Admiral made a comment earlier on uncertainty, like having uncertainty within that game. How do you do that? How do you create that uncertainty? It's hard to test the validity of a war game, but there's something to be said for those that go through the wargaming process, that they come out of it in terms of their feedback with a new view on some subject. And I'll give you an example. So recently I ran a war game for one of our seminars that was going to Sicily to study Operation Husky. So I'd been part of this seminar last year, and we had read a book on Sicily. We had endless discussions on Sicily, on Operation Husky. We read Eisenhower's AAR. Then we went to Sicily, and we were on the ground and moved around and went to all the stops. And I think I learned a lot about Sicily. I could probably recite to you a lot of the history. I don't know if I could recite to you a lot of the whys and reasons why people did things. But this year, I came back and I went to that instructor team. I said, hey, what if we design a war game where we let the students fight competitively between the 3 teams? And the 3 teams I made was the Axis, the British, and the Americans, because there was a lot of friction between the British and the Americans. And let's execute this war game. I got so many doubters on that. I don't know if we should do it. We executed it anyway, and the feedback was tremendous. Like, this was the best learning experience in this whole cycle. Well, why is that? It's not because I created a great war game. It's because it created an opportunity for them to get into the shoes of the commanders and visualize that war game. And to my previous point, it was all contextualized with their readings, with their discussions, followed up by a staff ride and AARs that went with it. So that's where that war game had validity in terms of its ability to integrate within a bigger picture of training and education. The last point, I think it's incumbent on us when we look at the purpose of simulation to step back, because I've had to do this recently in my current department. What if I don't have a simulation? What do I do? I think that process of going back and asking how can I do this how can I meet these same training objectives or these educational objectives if I don't have a simulation, will bring you to the point where you say, this is where I need a simulation. An example I'll give for that is I run one annual exercise. It's about 300 people it's called the Joint Land Air Sea Strategic. And so I am the exercise director for this, and it combines the Navy War College, the Army War College, the Air War College, the Swedish Defense University, Chilean War College, Nigerian War College. You get the point. It's a very large group to integrate together for a war game. We have no simulation running that. And so it's given me the opportunity to step back and look at this exercise we create all with text and all manually and all adjudicated by humans, and takes a massive amount of people to run. I think, where can simulation best be used? And that kind of inductive approach, I guess, of where can simulation help us as we move forward has been very revealing to me as a simulation professional, to understand where simulation is valuable and where human intervention is valuable. So my third thing I thought about was that. So those are the three things that when I was asked by Colonel Verde, what would you want to say to the MOVES group, 12 years separated from it, after being in multiple jobs as a simulation professional? That's what I want to say back to you, is to think about those things. Don't get so enamored with the tech and the tools that you forget about where it's going to be used and how it's going to be used. You're going to work for commanders. Ultimately, especially us in this uniform, we end up being advisors to commanders. And we advise them on the use of these tools. And if we're not the ones informing them how they're best, most effectively used, then what are we doing? So we shouldn't be so focused on the glorious tool we create, but rather how is that tool going to be used bigger? And that's what I commend to you to think about. And I hope that I'll be a helpful way to look at your education here, because again, I go back and I'll start at the start. I'll finish at the start. This was a phenomenal experience for me. Life-changing moves. And it was life-changing for many people that are my peers and my mentors. And the Army gets incredible value from this institution. And as Colonel Verde said, I don't see any time soon that we won't have a commitment to this institution, even though this was a very Navy day. I know I can read between the lines and know that the real intent is to support the joint force and to do the right thing. So thank you for your time. It's great being back. Thanks.
Great. I'll take a question.
Got one.
Yeah.
So, a lot of times for us, it's a lot to ask to say to consider the whole training cycle and the tool as used in context, because we don't have any influence over it.
Right.
You know, you might, but we don't. So we need to kind of be spoon-fed, honestly, if you and if by me, I mean all the people that are just tech, whether they're in industry or in other academic institutions, you got to kind of say, yeah, here's an example. You're not thinking about an AAR, and specifically what you left out is something like this. I need to be able to graph the force strengths over time. I need to, we didn't let me reverse time easily. I need to be able to scrub through the dispositions of forces very easily throughout the whole war. If whatever it is that you know would actually be useful, that would be great.
Yeah, so that, I guess I would answer that with saying my message is to those that are wearing the uniform and who are supposed to be wearing the uniform that aren't. Just kidding. Just kidding. Just harder to identify you. I'm really saying that to the uniform personnel, that as Captain, what was his name? Captain Sherrod, is that how you say it? As he said, you know, the warfighters coming in here, they're coming with experience and they're departing here to go back into that force. And so my answer to that would be, they should be talking to you, the experts in the room, and leveraging that experience to think about these tools that come here to work in terms of that context and not necessarily the context you offer, because you want to hear that. You want to hear, how is this going to be implemented in the force? Is this useful? Is the user interface acceptable to that? But from a bigger picture, how would this tool actually be implemented to be effective to make a better force?
All right, maybe we need to be asking the students that explicitly. Maybe I'll just say it for myself. Maybe I should be asking them that explicitly.
I was just gonna, kind of more almost a comment back to Chris, but, both Chris is really, I think one of the challenges also is the application of the tool, in the context of Naval Postgraduate School. You don't have the team of contractors or the ways that you're able to implement it in the fleet. And to the point that you made earlier about low overhead tools being utilized, I think that's also another reason, is that sometimes the ease of access and ease of utilization lends itself towards those tools. But yes, I prefer to have the higher fidelity for the plan post exercise. I can't really justify the exercise life cycle and the manpower and support that comes behind doing that. And so I think those challenges are related to what is offered as far as, here's your practical, this is a system that you're going to see or a tool you're going to see. It's a lot to ask for a couple of professors and students to be able to kind of work through that. So I think that's sort of related.
Yeah, and to be clear, I'm not asking professors to work through that. I am asking students to think hard about that whenever you're trying to approach a solution, how it could be implemented or how you may be implementing those solutions. I think you stated well why the low overhead solutions are used, but that's the reality.
Right.
When you pull off a command post exercise and you have a simulation that's been designed and developed to have that kind of resolution, and it requires 200 bodies versus a low overhead solution that requires 10 in support, what are you going to choose as a commander? And that's the reality that we in the uniform should always be thinking as we go through this process that moves, so that on the back end we're better able to work that out. Dr. Sanders, good to see you again.
Hi, thank you so much for coming and sharing the thoughts with us, and for repeated guest lectures and groundbreak. Whenever we are short of people, we go to you. So Jesse's here, and that reminds me of endless issues with adoption, diffusion of innovation, adoption of technology. And I remember a number of conversations that we had with him, and what we do as well on how much time. You finish your degree here, you go back to your services, how much of your time goes to advocacy and advertising? And to some extent, Jesse, confirm if I'm wrong, most of the time is spent advocating and talking to units and promoting rather than doing the work.
Yeah.
But it's inevitable. That's just, you have to recognize that.
Yeah, it's probably a fourth bullet I would put up there.
Right. And
So you're going to be a marketer in many ways.
Very much,
Yeah.
yes. But you have very, very important role. You are change agents. I'm not, but you are.
Yeah.
Because you are closer to end users in a way that I will never be able to do. And so there's really great need to have more of you and having coordination, and we would love to collect the data. I hear your comments, and I really take it, especially because I'm very much interested in adoption. So I would love to continue working with you on just understanding the space of adoption, what you get into when you have to promulgate and work on adoption.
Yeah. I think one of the number one messages that I've given to commanders successfully throughout the years is upfront telling them this is one tool in your toolbox. It's not the whole tool. Because I think that, honestly, I think that misperception that I can just walk into a mission training complex, which was what we call our Army simulation centers, and that what will go in there is an untrained unit and what will come out is a trained unit, is the perception among many. And if you don't say this has to be well integrated into a training path, and it has to be finished up with leading to something else, including a feedback loop that leads to probably a live event or a CTC. If it's not built within that structure, I'm useless to you. So that's why I give the hammer example versus, you know, something that builds you a custom made house. That's not what we are.
Sir, I appreciate you giving your definition of wargaming. One of the things I've seen is we don't have a common definition of it. And so 5 people around the table, we each have 5 different ideas of what they're getting out of a war game. And unless you sync that with an intended common purpose up front, causes some issues. But really getting to my question, you mentioned a wargaming process. Do you at the Army War College have a codified systemic process for design, development, and execution of war games, both generally and specifically for the intended purpose of education?
So at our strategic wargaming department, I'll go to the end of that question first. We really support 2 areas. So on one side, the CSL, the Center for Strategic Leadership, supports the Department of the Army, the G3, as a DRU, a direct reporting unit. So we have obligations in terms of analytical wargaming to them. We also work for the Army War College, and we support education in the classroom for that kind of thing. In terms of a process, we absolutely do have a process in which we have a sponsor come in, identify the objectives, much like the Navy War College, who in some ways I think does this much better than we do in the Army. I don't know if anybody's worked with the Navy War College's wargaming department. They're more focused on analytics most of the time than we are. I would say we have a bigger share of education. Not that they don't do it. They certainly do some of that for the Navy War College. But we follow much the same process they do in terms of working with a stakeholder, identifying requirements, and then up front, identifying where it sits within the big process, as I discussed earlier, is part of that process as well. But to your comment about definition of wargaming, the anecdote I'll give is I was at Columbia University about 3 months ago on a panel talking wargaming, and there were 5 of us on the panel from across think tanks and the services, and every one of us gave a different definition of wargaming, and we all kind of laughed because that is the nature of wargaming. I think it's important in the process you asked about to be very clear up front how you see the definition of a war game before you go into producing one for somebody.
Thanks, sir.
Any other questions? End of day. I'm surprised I get questions. All right. Thank you very much.
That concludes our presentations from day 1 of the 2023 Moves Open House. If you enjoyed these talks, the talks from day 2 and day 3 are also available. Please see the description below for the links. Also, the 2024 Moves Open House will be held June 4th through 6th at the Naval Postgraduate School in Monterey. Please see the link below for more information. The QR code at the top left will take you to the same page. Registration is now open from that site, so please join us in 2024 to see what we're currently doing.